Okay, so this is a course, guys. So this is what our course is, and what we plan to do is, anyone with zero knowledge has to go to a hero knowledge or a hero in especially in Azure Cloud and DevOps. The reason behind this training is anyone who's from a different background or who's already a system administrator or who's already in an IT in the IT field can learn about cloud because that's the first thing. The second thing is, you guys can get into DevOps, and our DevOps based course is on infrastructure based DevOps course, right? So we have divided this course into three phases. So what do we do in phase one? Phase one, you have, we will try to build the basics, and we will strengthen your inner, you know, uh, development for cloud and all. So what are we going to do in phase one? Phase one is we're going to start with introduction to virtualization and cloud, where you'll be learning about virtual machines. You'll be able to create virtual machines on your own using your own laptops, and you'll also be learning what cloud is. And when you learn about cloud, we'll teach you in such a way that you'll also learn the inside cloud, or you call it the under cloud. What is actually happening when you create a VM? What is actually happening when you create a service? What kind of requests are being made and how they're being made? Usually, when people train, go to teach in a training class, right? They will not teach you what are the inner mechanisms, and it's very important because you need to understand what is happening under the cloud. Once you know that, any cloud is easy for you. I mean, you can seamlessly switch from AWS to Azure or Azure to Google Cloud in within a matter of weeks. That's not an issue. All right. Then we're going to start with AZ900. AZ900 is the basic course, basic introduction to Azure Cloud course. We're going to go about, Azure CLI. We're going to learn about a little bit about PowerShell. We're going to learn about ARM templates. We're going to learn about scale sets, VMs, a little bit of VPN gateways, etc. Before doing that, we'll also be learning. Probably we'll have a session or two sessions on networking as well, because networking is one important factor that people often tend to oversee, and they don't really put that much effort into networking. We have to learn about at least till load balancing, IP switch routing, and you need to know about the IBs. So we're gonna dig into that. And once that AZ900 is completed, we will then jump into 104, which is the administrator course. So in that, we'll go a little higher, and we'll go in little in depth, and aim to cover topics in such a way that you guys can take the course. Meanwhile, after the even before that, we will give you guide you in such a way that we will tell you how to get your free coupon for your AZ900. There are several trainings that Microsoft conducts where if you attend that webinar, right, you will get a free coupon where you can apply in and start your AZ900 journey. This phase is, expected to take about a month. And what will you get from this phase? If you have successfully completed this phase, right, you can apply as an Azure administrator in Naukri or wherever job portal you have, right? You can still take this knowledge and start applying for jobs as a cloud administrator in Azure. So that's phase one. Once that's done, you are a certified. I mean, if you take a certification from Azure, you are a certified cloud Microsoft certified Azure administrator. AG104 will be on exam, and also it will be knowledge perspective. So once that is done, once cloud is done, now the other thing is now you need to know how to work in a team or as a team. Rather, an administrators work with other administrators, right? I mean, they don't really get into developer's mindset, or they don't really work with the developer. All they do is take requests or the tickets and creating an environment, and they'll do create the environment. But the next thing is, you need to understand how to work in a team-based environment. You need to understand the entire development life cycle and how usually the teams are working. So that's the reason why we put SDLC and Agile into this. In this phase, a trainer would, a certified agile trainer, a safe trainer, will be joining our class. We'll be taking at least 1 or 2 sessions, and they're going to explain you about the different phases of software development life cycle, and also the agile and scrum methodologies. With this knowledge, you now understand how to work in a team, and how the team works, and how the projects are being run. Once this knowledge is there, we'll move into phase two. Phase two is where we will start with the introduction to Linux. You don't have to get deep into Linux. There are about 20-25 commands that you have to at least learn and master in order for you to follow along your journey as a DevOps engineer. Once this 20-25 notification 20-25 commands are learned, right? I mean, they are, you have to practice basically. Once this is done, you are good to go. You can open the terminal, you can put commands in, and you can troubleshoot, etc. Once the introduction to Linux is done, we're going to get into intro to DevOps, which is going to take about 2-3 sessions, where we're going to make you understand what does a DevOps engineer do, and what is this whole word DevOps means. We'll take you through high level, and with that you will understand, okay, you know what DevOps means, and you know your role as a DevOps engineer, and you know what to do. Now, after that, we have several tools that a DevOps engineer uses. So some of you don't have to master all of them, but there's a complete build cycle that we use, right? That build cycle, you have to use several tools. So what we did was, we in the phase two, we're going to introduce you to all the tools that we think that are necessary in order for you to master. So what we'll do is, in a step by step manner, we will go into the intros. We'll go intro to Git. We'll go to the intro to Jenkins and Ansible. These are the tools that we will give you an intro. And intros are not are about 3 to 4 days long. Depends. We'll also install the tools, and we'll also run the tools, and we'll do deep dive sessions together. And once that's done, you are now ready to progress your career to a harder level. When I say harder level, this is where the things get really hard. We will start getting deeper into containers, Dockers. This is expected to take about 1 to 1.5 months. Once that's done, we are planned for phase three. Phase three is where we get all deeper into the technical stuff. We will implement an entire CI/CD implementations using the knowledge that we have gained over phase two, right? And that once that is done, so since we have also introduced since we have also introduced you to Azure as an administrator in the beginning, we thought it would be a good idea for you to take the Azure DevOps course. Once you're here, you can either apply as a DevOps engineer or an Azure DevOps engineer in the market. Okay, but you'll be at a little beginning stage. After that, we have introduced we are getting into intro into Kubernetes, where we will be building pod everything from scratch. And after that, we have introduced infrastructure as a code, where we use Terraform to build entire environments. And after that, once that is done, we've also introduced 3 bonus sessions, where we are going to introduce you to Packer. And we are also going to, since we did not touch much of monitoring, we thought it will be a good idea to introduce monitoring into the series, where, we'll be using Kubernetes and Prometheus. And finally, signing off, we'll be also introducing you to DevSecOps. Any questions, guys? All right. Is my voice better? All right. Now, these are the courses that we have planned. And within all these courses and all these introduction courses, we have also planned several POCs and several projects. Okay. And based on that, we will be, assessing you, and also we'll be taking inputs, and we'll be working together. These are all of the weekday courses that we have planned. And during the course of this week, sometimes we are planning some sessions on Saturdays. Guys, questions a little later. Don't ask about technical questions now. Let's go, and I'll give you some time, and we can take your questions. So there will not be any Sunday sessions, but we are planning for Saturday sessions where we will be working on demos, labs, or other course. I mean other courses. All right, guys. Okay, I'll give you 5 minutes. We can answer questions now. Or is it
Yes, Sandeep,
just a
please check
second
the
then?
mic. The voice is not clear.
Is my voice clear to everyone or is it breaking?
No, no, it's not clear. Some disturbance is coming.
Just a second, guys. Just a second. Morning timings and regarding the labs, what we do is once we are at a level where we need to showcase you something, we will showcase you the working, and then we'll plan a lab and we'll add it in the course. Yeah, we're going to plan. I mean, we're going to cover PowerShell also, and no, we have several instructors. In fact, we have about five instructors. They'll be covering in the course, I mean, the entire training course. No, we are not going to cover deeper into microservices, but we do have plans where we build out in different languages. So Azure DevOps is basically a suite of services that Azure Microsoft provides, which are integrated. So there's a CI/CD aspect to it where we'll be using entirely Azure services to build the CI/CD. Other DevOps, I mean, that's the main reason. I mean, other DevOps, we have a different suite of tools that you can use to build your own pipelines and run the show. All right, duration of the class would be about 1 to 1.5 hours. Today, we're going to most probably see how it goes. We have to cover a lot of topics, right? So it is maximum 2 hours. Will not get you to close to 2.5 hours. But yeah, 2 hours is the maximum time. Okay, so this is me. I'm Sandeep Togarati. I work as a director for a company, and I've trained more than 2,500 people till now. So I was a pilot back then, and I was a dropout from while I was flying. I used to work for a company called Kingfisher, and I didn't know what to do, so I came back to India. After that, I saw my friends and all; they were in IT, right? So I thought, okay, I'll get into IT. So I got into IT, started working as the desktop engineer, right, in HSBC, where I used to build desktops for my clients. When I say clients, those are the employees. So slowly, I started getting into server. After building desktops, I started getting into building servers, and then I thought, hey, this is nice. Why not I continue? At that time, we didn't have had this privilege of going to instructor and learning something, because they used to charge like crazy amounts. They used to charge at least, I don't know, 50,000-60,000 per class, and cloud wasn't there at that time. So it was there, but I didn't know about cloud. There was no one who would preach me about cloud or preach me about DevOps or anything like that. So we used to I mean I used to, in fact, learn about cloud and all the virtualization concepts from the internet. There are several white papers that people published, right? So once that is done, after the server engineer, I started looking into VMware, yeah, as a hobby, because VMware was so costly at that time. HSBC didn't approve that license. So I downloaded a version of it, which was community version. It's called VM Player or VM Box. I don't remember now. So started getting into virtualization. Then this idea intrigued me of me creating my own servers. Earlier, it wasn't possible because a server is a costly device. You cannot basically get access to it until and unless you have permission from your manager and his manager. So once that is done, I started studying virtualization, and I moved into another company as a virtualization engineer. And I learned a lot of things there. After that, I mean, then I saw that there was cloud. There used to be all this hoardings all over the. I used to work in Hyderabad, right? There used to be hoardings all over the place. That's when Google entered Hyderabad, and they started putting big posters about cloud. I didn't know what cloud was at that time, so I started learning what is cloud, and started getting deeper into it. Once I had I thought, I had enough experience. What I did was, I started applying for jobs. Nothing. I didn't know I didn't have solid experience of cloud, and I didn't know what cloud was really, and I didn't know how to build it. But I started, applying for jobs. Slowly, they started rejecting me, and yeah, I mean, I got clicked. I mean, it clicked, right? I went into Accenture at that time. Then I learned on the job. So I was in a motive where if you don't practice, you won't get anywhere. So I was in Accenture for about one and a half year, where I started the entire BU there on cloud regression and automation testing too. There's this tool that I co-developed for a cloud software called OpenStack. It's called what's the name I forgot? It's called oh, Cinder or something. I'll go look it up and tell you guys. After that, I became an architect, cloud architect, and now I've been working in the same company for the past 8 years now, where I grew up ranks, and now in a position where about 120 people report to me. So meanwhile, I used to do gigs as a corporate trainer. I trained people from Accenture, AT&T, Tech Mahindra, Cisco, Aruba, and things like that. After I moved to the new company, and I also did some trainings for I know your online, the big edutech companies. I mean, there are several videos of me on YouTube. The face is not visible, but I'm there in their courses. I thought, wasting my time for 4 hours a weekend day, and they charging crazy amounts of money to the people it wasn't worth my time. So I quit that, and we thought of starting North for about 2 years ago, and now we hit it off. And idea and goal is to make education free. I mean, free to everyone. So that's about me. I got feedback last in the last Q&A session that I didn't give enough intro about myself. So I am server architect with infra, that is private cloud, public cloud. I worked on all the three clouds and also the infrastructure part of it. I've been to several uh, cloud summits where I presented my notes and my presentations there, and I've trained a lot of people, and I'm here to train you guys. All good. All right. Okay. Now that's enough about me. And let's go to the uh, let's start with the basics today. I know most of you know what is happening. Already know what is already in your computer, or about computers and all. But for the folks out here who would like to learn more about what a computer is and what parts you have in it, we're going to take a look at what is inside a computer. The reason why we start with this flow is because you are going to use these terms in cloud. When I said these terms, you will definitely use all of this, most of this, parts that I talk about in cloud, because you're the one who's building everything, right? Let's go. So this is a typical computer, right? I mean, you have a CPU box and all, and some of you or most of you use laptops, which is a slimmer version of this, correct? So did you ever think about what is actually inside the laptop or your desktop? See, these are the parts. These are the physical parts that you have inside a computer, or within your laptop, or anywhere a computer, anything that you use. Even your mobile phones have a motherboard or a CPU or a RAM or everything, right? You guys have everything. I mean, and we have these parts housed inside a computer. Now, did you ever look what is actually holding this? A motherboard, right? What is a motherboard? It's like a board that houses all the applications. Sorry, all the physical items together. And a motherboard is capable of holding CPU, you have RAMs, you have hard disks, you have graphic card, you have power supplies, you have cooling fans, you have a lot of ICUs, you have everything together. That's what, and there has to be interface that connects all of this together. And that interface is called a motherboard. Now, the first and fundamental thing that we talk about is a CPU. What is a CPU? CPU is a central processing unit. It is like the brain of a computer, where it'll basically give the input and output to the programs that are requesting it. And there are several programs that control direct that you can control the CPU with. One being C program. All right, and usually the CPUs are marked with cores, right? I don't know how many of you heard about i9, i5, i6, not i6, i3, i5, i7, i9, and most of your laptops are i3 or i5. What does that mean? They are basically putting a sticker on your laptop saying, hey, CPU that you have in your laptop or in a desktop is an i3 or an i7. That means it has 7 cores inside it. It's worth that core. And you have an aspect to it, which is called, they write a gigahertz number there, which is called, let's say, 2.8 gigahertz or 1.7 gigahertz or whatever. So what does a CPU mean? So each core in a CPU, right, has a value in terms of when you take it outside. One CPU core is equal to 2 virtual cores. So what happens is, when you have an 8-core CPU, okay, these are physical cores that are built on top of your CPU, because those are in turn made of millions of transistors. And what do they do? Transistors basically have a capacity charge, electric charge, that they discharge and charge. So the million times that they do it, you get the electricity power to CPU, and the more you get it, the more powerful your CPU is. So like this, those millions of transistors are divided into 8, let's say, a core. Okay, and that core can be virtually extracted as a two virtual cores. So whenever you hear someone saying, hey, I have a 2 vCPU VM, that means actually it is basically using a 1-core CPU from a direct host machine, but he's divided that into 2 vCPUs to break the thread for his VM. Got it? So that's about a CPU. I think my bad. Yeah, there. And the next thing that you talk about, RAM, right? This is a favorite topic. Hey, how much GB is your phone, right? I mean, I have a 6 GB phone, I have a 10 GB phone, I have a 16 GB phone. So memory is like, random access memory, right? It's a human brain. It will take the items that is ready for processing. It will hold that into the memory cache, and it will release it whenever it's needed. It's for, fast access. And memory is usually, measured in GB, gigabytes. So when someone says, hey, and when a request comes to you saying, hey, I need a VM with 6 GB RAM. So what is exactly happening? You're taking the 6 GB RAM and giving it to him, and the RAM is nothing but memory. We call RAM as memory in our terms. So memory is not your hard disk space, but memory is the random access memory. Okay, let's go. And you have a network card. The most important thing for a computer is a network card. In order for you to connect outside, or connect to your friends, you talk to your friends, we have a network card. And our network card is about 2 types. Let's say you have a Wi-Fi adapter in it, that also comes under network card, and a physical network card, which you plug the cable in. Now, even if you have it in your phones, you have it almost in every computing device that connects to the outside world. And there's a circuit board that has that the network card is housed into, and that is where we usually plug in the Ethernet cable. And you have speeds for this network cards. Let's say 1 Gbps, 10 Gbps, 5 Gbps, or you have it in kbps. And when a network card is 1 Gbps rated, that means the maximum amount of data that it can send and receive is 1 Gbps. This is very important right now for you to understand that a network card is a must for you guys to connect to the internet or through the LAN network. And the second thing that you have is a power supply. Power supply is a unit and box that you have within your laptop or your computer, where it converts the electricity AC into direct connect, because that's where it converts that current into DC, and it supplies it to the motherboard and all the transistors that are there inside our computers or laptops. And it's usually measured in watts and kilowatts. So you have 800 watts power supply, you have a 400 watts power supply, everything. This is the important one of the important components that goes into your CPU and that goes into your computer and your laptop. And next thing that you have is just storage. Storage is nothing but a device that holds data, correct? And that data is to provide access to your other peripherals that are inside your motherboard. So what happens is you can install an operating system on top of a storage, correct? Without a storage, where is the mean of communication? The communication will not be there until and unless you put a hard drive in your system. And hard drive is usually measured in KB, kilobytes. You have a GB, 1 GB hard, 10 GB, and you have terabytes and petabytes, etc., etc., etc. Just a second. Okay, I'm back. So one of the important peripheral that goes inside a computer is a hard disk, and then you have an operating system. Without an operating system, you cannot do anything, right? You cannot operate, and you cannot connect to the internet or connect to Word or Gmail or Facebook or Instagram, whatever you do. Without an operating system, a machine cannot be running. When you say even your systems have your operating, phones have your have operating system. You have Android, you have iOS, you have everything, etc. An operating system does is it basically connects to the hardware or CPU, right, with the data that is on the hard disk to make changes and take computing power from the CPU and operate. So even applications use the CPU, right? Threading, people call thread. It's called threading, multi-threaded application or code, etc. So you cannot do anything without an operating system. So think of it this way: when you're building a computer, you need an operating system, you need CPU, you need a RAM, you need a motherboard, you need a power supply, and you need a hard disk. So all 6 or 7 elements go into the CPU box or the laptop casing, and they will be able then you'll be able to install an operating system and utilize it. And now let's move on to servers. Any questions for the computer, guys? Let's take 3 minutes for the questions. No? Okay. Okay, cool. I guess you guys already know what is happening. Okay, good. I'll tell you the reason why I'm starting with those those low-level items, because you will be working as as a cloud admin or as a DevOps administrator or DevOps engineer. You should be knowing some critical items that go inside a computer. The reason being, let's start with our server. Okay, the reason being, cloud is nothing but an encapsula, or a big name for virtualization in a large and huge scale. And how are this those cloud how a cloud is made possible is a term called virtualization. And virtualization is a software that sits on top of your computer or your server, and that will utilize your server's hardware and start building machines, etc. Now Let's talk about tower. There are three base. There are three kind of towers that you see in a data center. One is a server tower. Server tower looks like a CPU box, but is utilized. It can be utilized in and put in a rack together. Okay. The next one is you have a rack server. This is what we most of the companies or data centers typically use. A rack server is like a horizontal kind of device that gets attached and put into cabinets or racks. And you have a blade server, which is sorry, that image is of a switch. So you have a blade server, which is a thinner version of a rack server, which is used for specialized computing. And blade servers can be with or without storage devices, because you can utilize and grid them all together. So these are the rails or shelves. If you look at it, you have a tower server, and you have rack servers. You have all the cabinet, all the servers installed inside a rack. It's basically like a storage device, a big storage device where you put all your clothes in, right? The same thing you do it with the rack servers and the servers that are there. And it's important to know about this, because at the offset in a data center, the servers are not kept everywhere and anywhere. They need to be installed inside racks, and several of these racks are inside a data center, which are interconnected together and interconnected with each other through networking, and we generally call them server farms. And a server farm is nothing but a collection of servers. When I say servers, and a collection of racks. Now you know what goes into a computer. Now you know how a rack server looks, and now see how the rack servers are being connected, and they are connected to each other using networking. The reason for them to be connected is for pooling of resources, or getting them into a same single cluster, and using them for the outer world. Now you have this server farm, right? Now, if you put them inside a data center, you have several farms together. That means you have several thousands of servers inside racks and connected to each other, and they're housed under one location, and you call it a data center. Okay. And data center is one physical location, or one floor, or one building, whatever you call it, one housing where you have several server farms, several racks, and several other servers that are interconnected to each other in a single location. Now, what if you run out of space in one data center, or you plan on adding one more data center to in another part of the globe? So you have a region. You can call it a region where you say, hey, I have one data center in India. I want another data center in Singapore. So you go open a data center there. Now what is happening? You have two data centers in two different parts of the world. Now over there, you'll be like, okay, fine. I have two regions now. I have data centers in two regions. I want them to get connected. So if you connect them via networking or physical wires that go on through the say, cable and all, then you can see that those two data centers are interconnected. Now, if a customer comes to data center one and say, hey, I want a server, uh, what are the options I have? So I'll say, hey, I have two regions. You can either choose it in India, or you can either choose it in Singapore. So he says, okay, I have 10 customers in Singapore and 20 customers in India, but I want both of them to talk to each other, or the application to be accessible for both. I say yes, because I have two regions. My application is on both of the data centers, and yeah, you can use it. So this is one of the use case of having data centers and regions. If you know this concept, you'll understand availability zones in cloud. Simple. So the concept is every data center has several servers, and the data center has several regions. Regions being they'll be housed inside one location, and they will be putting them into all the locations or the location of their choices, and they connect each other by internet so that they have availability everywhere. All right. Any questions, guys? Let's take 2 minutes for the questions. Data DC region. Yeah. So Yeah, you can have any basis to select the data center, right? I mean, you need a data center for a lot of reasons. For example, to protect your data or to house some kind of data that is needed, and also to utilize a server, you can go there. Yeah, I mean, usually when you want to open a bank account, right? Where do you go? Do you go to a branch close to your house, or you go to some other a region or a state? You go to the closest one, right? That is one of the reason. And since you have a server in a data center, what you want to do, and your house, you have an application, and you have that in, let's say, suppose Hyderabad, and all your users are from US, right? So, and there'll be a latency there. So, is it better for us to host that application in Hyderabad or in the US? US, correct? So, yes. So that's one criteria. Data center sites, data server farm racks. Yes, that's correct. You can have, yes, that should be correct. That should be okay. Vivek. Okay. Uh, yes, good question. Yes, and that is also one of the use cases for data center regions. So in case one region fails, the other region can operate if they are operating in ideal conditions. Since we are at a very high level, right? I don't want to talk about availability, etc., etc. I just want you guys to understand how how it's being built under the cloud. Yes, high availability is a different topic. We'll get to that. High availability is something where you need your application. Your application is hosted on cloud, correct? I'm not on cloud. I mean, within a data center. And if the data center catches fire or someone gets COVID and they spread everything over there, your application is no longer available, correct? In order to mitigate those kind of risk, your application will be transferred to a data center in a different region, okay, and also in a different region, so that to make it highly available, let's say. And disaster recovery is almost a similar thing, but what happens is, in order for you to have a disaster recovery, once a disaster happens, how do you recover from that is something that DR means. So if a data center fails and you have a DR site enabled or a backup plan enabled in a different region, that will be that will be your application will be switched over to a DR site. Okay, Sandeep. Okay. All right, guys. So okay, got it. So let's start with the basics of virtualization first, and then we can call it a day. And tomorrow we can continue with virtualization and a demo on how to create your own VM. Okay. So now you know about data centers. Now you know about servers. Now you know about computer parts or components that go inside a server, right? Now, what is virtualization? So most of you guys know, if you open your task manager right now and go to the CPU usage, right, it will not be more than 50% or 60%, since you guys are not performing any tasks and it's idle. Correct. Now, people have been thinking, hey, I bought this beefy server. I bought this big server for $20,000 or 20 lakh rupees. And I'm only running one server inside it. And, I don't think I'm utilizing it to, to its full potential. And, I say, yes, you're not utilizing it. You have to do something called a virtualization. And he asked me, what is a virtualization? In its simplest form, right? Virtualization is nothing but taking the physical server and applying the virtual software on top of it and breaking that server down into several individual virtual machines, right? And that will be so good that I can utilize the server that you already have, and I can utilize it to the full potential. So that is virtualization. And you can use it for hardware virtualization, which is the mother. Spoke about the computer, right? You can do it for OS, and you can do it for storage, compute, and network. And when I say compute, compute is the CPU, guys. I mean, this is the compute is the CPU. Basically, it involves with creation of VMs and items like that. We'll go into that little deeper in the coming classes. But understand that compute has to do with the computer parts of CPU, memory, and CPU and memory. All right, and you can also virtualize networking. So what is the reason to virtualize? So you guys tell me, in order for you to create a server, right? Or let's say, I want to create a server and I bought it for 8 lakhs or 9 lakhs. I got it. And now what I have to do is I have to install the parts, correct? Install the software, connect it to a network, configure it, and then put it in a rack. Do you think do you think it's an easy job? No, it takes a lot of time and a lot of effort, right? And also, it takes a lot of space and a lot of power consumption, and also it requires cooling because unlike our laptops, like me, it always needs AC on them. Cooler has to be turned on. So that's one of the way that's one of the issue, right, for having physical servers around. So it reduces. So instead, what I say is, hey, I mean, I have the server, I want to put it in a data center, and I say to my friend, hey, why not we share? So the server guy will install a hypervisor, which is a virtualization software term you have to understand. I put it, I mean, install that hypervisor on top of it and provision my VMs in within the time of minutes. So it also reduced the cost because previously I had to pay for the full server. Now I'm sharing it, correct, with my friend. So that means two servers at the cost of one. And it's also, it also used for aggregation. It's like combining multiple resources into one. For example, you have a web server, you have a file server, you have any other servers, and those are all sitting on physical servers. And I want them to make them of virtual servers. So what I'll do is, I'll create 3 different virtual machines and install the softwares. And I say, my web server has to be different from my file server. So you can create that. You can isolate that particular web server with the file server by disconnecting all the loops and all the connections virtually. Yes, VDA also comes under virtualization. Yes, correct. So what all can be virtualized? The spelling of virtualization has been auto-corrected by Microsoft PowerPoint. Sorry, guys. Okay. All it should be Z and S everywhere. Yes. So aggregation. I'll park that question, Sandeep. We'll come back probably at the end of the class. We have. I think we'll finish that virtualization topic and come for the questions. Okay. So what can be virtualized? Server virtualization is called the virtualization of server, which we just spoke about, which is the PC or which is the computer that can be virtualized and made into several different virtual machines. And storage virtualization. Storage virtualization is the hard disk that we spoke about, right? Now, remember, hard disk has two kinds of meanings. One is the actual system hard disk that the computer uses for the operating system to save your files, etc. And there is and there's another storage that you can store files on, sort of like your external hard disk. So with the use of virtualization, you can even virtualize those storage devices so that you can share this to different VMs or different people on the internet. How many of you used Google Drive? A lot of people, all of them. I mean, almost all of you guys, right? Dropbox or Google Drive. Yeah. So that is one kind of software storage virtualization, guys. It's allowing you to store your files over there, and it's making it accessible. Correct? Now, yes. So next is memory virtualization. Memory virtualization is nothing but you have a memory which is your RAM, 8 GB RAM, and you want to create a system with 2 GB or 4 GB. You can give 2 or 4 GB to the end virtual machine using the memory virtualization. Okay, and network virtualization. You can create unlimited or number of virtual networks if you use the virtualization software for networks. And the other thing is the service virtualization. Someone was talking about JavaScript, etc. Right? Typically, you people write um, code which runs in a virtual machine, or sorry, which runs in a monolith, like your servers. And now, service virtualization can be applied on top of that, where you can use APIs. We can you can use you can put it on the cloud, and give it technology. I mean, you can give it features like high availability, etc. And you can make it truly virtual or truly agnostic and make it a microservice. Any questions, guys? Let's stop with this, and probably I'll take questions, and we can conclude today's uh, call. Okay, service virtualization. Okay, let me tell you what a service virtualization is nothing but uh, you can virtualize the service in such a way that it is available to different people on the network. Or let's say there's a Word, right? Microsoft Word. You have two versions of it. One is the Office 365, and you have your inbuilt Word. Or you have Google Docs, you have Google Word, Google, etc. Right? Where are you using it from? You're using it from the internet, correct? But there has to be a physical software. When I say physical software, or a software that is written and that has to be run in some server, correct? Now that is being virtualized using service virtualization. So you don't have to install that software anywhere, but it will be made readily available with a click of a button or using the IP, I mean, domain name. Understood? Do you want me to go a little further, or I mean, today's class is enough? Because I can go a little further, but we have to go a little deep inside virtualization. In data center, we have physical servers. Data center is built of physical servers, but they also run a virtualization concept called hypervisors that will allow them to distribute their physical servers into virtual machines, which we'll be utilizing to create web servers or file servers or any other servers. Okay. Good, good. Questions. Do you want me to open mic? All right. Let's talk about memory virtualization. Memory virtualization, Krishna. Okay, is nothing but it's like a CPU virtualization, and you have 8 GB of memory, and you want to create or you virtualize it. You can use hypervisors to take a part of it and attach it to a virtual machine. And network virtualization is also the same. So you have physical network, right? Yeah, okay, let's talk about network virtualization. You have a router in your home. What is it doing? It's basically taking the internet and dividing it and giving you some IPs, correct, for a local LAN. So imagine the same for the physical server, physical machine that you have. There's an IP that gets connected to your server. And when you're creating a virtual machine also has to have IP, correct? So network virtualization actually takes care of creating that router or network or LANs, which are called VLANs, okay, virtual networks and everything through your physical um, link. Okay. Any more questions? Good with memory and network virtualization? Come on, guys. I mean, I wanted to ask questions. Otherwise, I feel that you didn't get anything or I didn't train you properly. Okay. Today's session is very, very, very high level, and we will go a little deeper tomorrow. I mean, I want the starting class to be, you know, at least at a very high level, so that we know what is happening and we understand everything that's there inside a virtual machine, or sorry, inside a physical server. Yes, we are covering. Yes, tomorrow. Service virtualization. Yes, we have softwares, and you will get to know about it. It's not that complicated. It's basically the service or the program that you write will be put into several other virtual machines, and that will be made available for you into public use. Yes. Yes. When it spoke about networking, guys, a network also means IP, because when you install, when you put a network card in and when you connect it to the outside world, right? You need someone to say hello world. That means an IP address has to be there. So when a VM is created, VM will also get a will also get an IP, which is basically taken from the physical server. So a network is created. So for tomorrow's session, we'll be once the notes is done, I mean, or my talk is done, we will go ahead and install a software called VirtualBox. Okay, VirtualBox is a OS operate, I mean, hypervisor, software-based hypervisor, which can be used on an operating system. What that does is we have the ability to create a virtual machine using your laptop or your computer as the base host OS. Sorry, host computer. Sorry, I missed your questions. Wait. I want to deploy the same application on different data center regions. Do I need to pay for data center regions? Yes, you have to, but it's not that significant because cloud has come right now. No need of Azure for tomorrow's. Don't create, guys. Then one more thing, don't create any Azure accounts. No, no, I'll ask you. I'll tell you when to create Azure accounts. Only then you create Azure accounts. Okay. Yes, physical server also has IP. There's a physical server also has an IP address or subnet, so that VM makes correct. Exactly, Venkat, you're going there. Correct. Okay, guys. Yeah, I think we pretty much now know what goes inside a computer, and why I spoke about the parts. That's the reason why I spoke about the parts is because of these. You need to understand what parts your computer or the server has, so in order for you to understand how virtualization works. Because if you don't know what a CPU means or a memory means, you don't know how, you will not understand when someone says, I need this much memory, I need 8 gigs of RAM. And I'm sure that you guys know about everything, but still, I thought, hey, this is how it works. All right. Okay, guys, and thanks for attending. I think we got about 130, 135 plus people today. Once the class is done, the recording will be uploaded directly to the website, to your dashboard. And we will upload this PDF, this notes. And if anyone's taking notes, right, I mean, please do share with us. I mean, I'll be happy to take a look at them. In fact, if you guys are making notes. And one more thing, a WhatsApp group is filled. The first one is filled, and the guys who join, people who join in the coming 1 2 days, right? They'll be going to the new group. So if your friend is there in a new group, please don't double join. Tell us, we'll do something. PDF will be uploaded to your dashboard. It will take some time, probably 1.5 hours. And we will put the notes there. But the website, but the video will be available in the next half an hour. Yes, please join nosfer.com and go to your course. Everything will be there. Just a second. I'm opening my guys. Be please mm, all right. Go ahead. Nosfer's meaning is secret. I will not tell anyone about it. Or you guys can basically understand or guess it out.
Uh, I wanted to ask, like when you were saying,
Okay. Okay, guys.
like,
Then I think we're done for today. Let's
uh,
start. Let's get on call. I mean, in the meeting tomorrow. Will be our video will be uploaded and the course content or the notes will be shared.
so I had a
Thank you so much
question,
for
like,
Yeah,
joining
yeah,
and
Aparna,
have a
go
great
ahead.
day, guys.
You have some question, I think. Just go ahead.
yeah. So no, just a small question. I said, like, I heard Sandy saying that we can even share our notes. So whatever he is telling the notes on that, or what kind of notes he wants us to share.
Aparna, can you come again? Actually, your voice is very low and I'm unable to hear you.
Okay, I'll just
Yeah.
maximize.
Yeah, Aparna, actually, Sandy was asking, see,
Mhm.
when he was teaching, right, at that time, suppose if you are taking any notes,
Yeah.
so he's asking to share that notes with him. That's it.
Okay.
Yeah.
For the whatever we take when we okay
Yeah.
when
Yeah.
we hear him. Okay, I'll do
Yes,
it. Okay.
correct, correct.
Sharing is caring, right? I mean, you just share if you want to
Yeah.
share it with the other guys.
Okay. Sure.
Yeah, yeah. Yeah, thanks, Aparna. Thanks.
Probably we should have a contest on the best notes written. Probably we should give out something for them. Okay. Okay, guys. Thanks for joining. I'm signing off. All right, guys. So yesterday we stopped off by talking about what is virtualization, and today we thought about discussing virtualization, right? So basically, what virtualization is, you are taking a part of the physical host and you are virtualizing that part of the host, and in that process, you are creating an entirely new systems or new resources which are directly interconnected to your to your physical host through a layer called virtualization software, which is called a hypervisor, right? So why do we virtualize? Why do we virtualize? One, it's cost effective way. It's cost of effective because you buy a beefy bulky server and you pay a lot of money for it, and then it's only you cannot just use it for a single purpose, right? I mean, and you want to use it for multi-purpose. And but if it's a desktop computers, we have media, we have pictures, we have work stuff, we have everything and everything, anything on top of it. But when it comes to the real world scenario, when I say real world scenario, when it comes to organization, right? You will have to have it organized. So that means that everything has to be isolated from one and each other. So you have picture files or video files which are called your media server. You have files, documents, and all. You have a document server, and you have every other business proposal, some or emails called email server. But practically, it's not possible to buy a single server for all of this because one, there's a storage issue. When I say storage, you cannot fit 100 servers and you cannot keep buying, and so that it will occupy your space, first thing. And second thing is, a lot of cooling is required. When I say cooling, I mean you need to have industry grade air conditions to cool the servers because they'll be running 24 by 7, correct? And third thing is the power that you're utilizing. Imagine powering one server and imagine powering 100 servers. Your power costs are going to be 100 times more, right? So they have come up with a scenario called virtualization. So basically, you are splitting your servers or physical servers into different kinds of virtual servers to save space, time, money, storage, and everything. Okay. So that will be the basis of why we are using virtualization. Got it? So why do we virtualize? Like I told you, faster provisioning. For example, let's say you are working in an IT company, and I know, I mean, even if you're not, right? Tomorrow, if you're going to join a company, some IT organization, what's going to happen if you're a developer or if you want something to practice on? There are different servers that you might need, and what you do is immediately raise a request to your IT service person, right? Hey, I need a server. Can you give it to me? Typically, if you're doing it in a physical world, when you call a bare metal way, bare metal is another word for a server. Bare metal means a server with nothing on top of it. When I say nothing on top of it, nothing installed on top of it. So you need the IT server, the IT person cannot go and purchase a bare metal server and install everything on top of it, because it's going to take time, first thing, and it's going to cost money. Imagine 100 people joining and 100 people asking for 100 servers. Your IT person cannot go purchase 100 physical servers and put it on top of each other, right? I mean, servers will be occupying more space than employees. So virtualize. So, and also one more, what happens is, imagine you have a bare metal server or your physical server, right? And you install an operating system on top of it. So what if there's an issue with the bare metal server, or what if, some part, your CPU or a power supply or hard disk or motherboard just fries or, goes wrong in your bare metal server? So that means your entire operating system is gone, right? Your entire work that you have saved in the operating system, the files that you have saved, everything is gone, right? Because your physical server is gone, correct? That's one of the reason you virtualize. And the second reason other reason why you virtualize is scalability. So you can easily create servers with, different OS within minutes. And also when you virtualize, what is going to happen is the OS that you have will be tied to the hypervisor and not to the bare metal server. So let me show you how that works. So you have a bare metal server, correct? And you install a type 1 hypervisor, which is nothing but the software that goes, virtualization software that goes on top of a bare metal server. And let's say and you have VMs on top of it, right? I mean, so you're virtualizing. Basically, you have VM1, VM2, and VM3 on top of your hypervisor. So what if something goes in the bare metal server? So the single point of failure is not your bare metal server anymore, because your VMware, your VMs are tied to your hypervisor and not to your bare metal server, right? So all the VMs are on top of the hypervisor, but are not up on the bare metal server. In the event that this fails, what's going to happen? You just have to take another bare metal server, transfer your hypervisor to that bare metal server, and move your VMs back. Got it? It's as simple as that. I'll just give you a couple of minutes if you have any questions. All good. Software means not OS. Software is the example of a hypervisor. For example, you have Hyper-V, and you have VMware's VMware hypervisors. So those two work. Bare metal means a fresh server. When I say bare metal, a server that is purchased from HP or Dell or something like that. So on top of bare metal, we have two hypervisor. We can install a hypervisor like you install your OS operating system. We'll install a hypervisor on top of a bare metal. Yes, we install hypervisor on top of a bare metal. VMs are nothing but virtual machines. Virtual machines are tied to the hypervisor because it will basically virtualize whatever hardware you have and make a new system. Yes, every VM can have a new OS. Whatever OS you want, we can do it. Correct. That's correct. Shall we proceed?
Sandeep, there is one more question from Harika. She's expecting what exactly is a hypervisor?
Okay. 1 second. Example of hypervisor. Okay, what is okay? A hypervisor is a collection of kernels or softwares within, like an operating system, right? You install Windows, correct? What does Windows do? Windows will go and talk to your hardware or CPU and say, hey, my name is Windows and I want to work with the physical, accessories that your physical components that you have. And CPU has to provide me with all the information, and I have enough software so that you can understand. So same thing, and once that is done, Windows is formed, right? An operating system is been installed on your computer. The same way, hypervisor is also a software that works typically or only for the purpose of creating virtual machines or the physical hardware, and only for the purpose of virtualizing the physical hardware lying on the server. Got it? So it is like an operating system, but it's not an operating system, guys. It's like an operating system that has the ability to talk to your. No, Docker is not an hypervisor. Please wait. So it has the ability. Yes. So it has the ability to talk to your physical hardware. Okay. And give it the functionality to take that hardware and virtualize it using virtualize it so that you can create new resources out of it. Got it? That's one type of hypervisor. That's called type 1 hypervisor. Let's go to. So what all can we virtualize? Yes, we can install hypervisor directly or bare metal server. We see there are two types of hypervisors. That's type 1 and type 2. We're going to cover next, Manoj, just a second. Okay. Yes, if the hypervisor is down, all the VMs will be down. But there are ways to mitigate that, that is a different topic altogether. But I'll give you an overview. Yes, if base machine crashes, the hypervisor is still active. So hypervisor can be transferred over, or the VMs can be transferred over to another hypervisor. Okay, so what all can be virtualized? So we have server virtualization, which is nothing but what we talked about. And we have storage virtualization. Remember, I spoke about hard disk and everything yesterday. That can be virtualized. We spoke about memory virtualization. Remember, we have memories in 8 GB, 16 GB RAM or memory. That can be virtualized. You have network, which is a network adapter, network NIC card that is there. You can virtualize it, virtualize that, and that plays a lot of important factors for us going forward, because networking is something that people rarely look into. And if you don't know the basics, you will really struggle in your future roles as a DevOps engineer or a cloud engineer. Okay, we'll talk about networking tomorrow. And application virtualization. We'll talk about all of this today, except for network virtualization, because I'll take it tomorrow when I introduce you to basics of networking. So what is server virtualization? Like I spoke about, taking a physical server, installing a hypervisor on top of it, or installing an OS on top of it and a hypervisor on top of it, and making a VM available is called server virtualization. There are two types of virtualizations, hypervisors available. One is type 1, which is basically basically sits on top of a bare metal server. And the other one is type 2. Type 2 is something that you can install it on top of the operating system. We'll take a look at them using small diagrams, and we'll understand what both of them are. Okay. So just remember, guys, that there are actually three, but I think you only have to understand two. Type 1 and type 2 are the main ones. Type 1 is the server, is the hypervisor that goes on a bare metal. And under the cloud, 90% of the cloud, or more than that, in fact, uses type 1 hypervisor. Okay. There's something called type 0, which you can install both on bare metal and software, but it's on Linux. If you want, we can, I'll give you the reference links in the notes today. And there's something called type 2 hypervisor, which basically sits on top of the operating system and lets you create virtual machines. And for today's demo, we're going to look at type 2 hypervisor, because we cannot install because I don't have a server available which is free and we can install it. But we can take a look at how virtualization works using a type 2 hypervisor. All right. So this is what is actually a server virtualization. So we have a physical server, right, on the bottom right side. All right, one second. Yeah. So we have a physical server there, and if you look at it, there are different servers that are sitting on top of it. Meaning, what is happening is, with the use of a hypervisor or virtualization, you can run different VMs or different servers. So here in this example, we have a database server, file server, email server. Similarly, you can have a streaming server. You can have any server that you want once the server is virtualized. So we have two types of hypervisors. Type 1 is bare metal. Type 2 is software. Yes. Yes, we can use type 1 for data centers, type 2 for personal also. But there are some use cases where type 2 is also being used in several companies. So all you guys have to understand is, because of a hypervisor, you're able to create VMs using the underlying infrastructure. When I say infrastructure, we spoke about the important parts of a computer yesterday, right? All of this will be can be virtualized using a software called, or a term called hypervisor, which is nothing but a virtualization. No, there will not be a load on the server, because typically our servers that we install or that we put in, right, will not use their max capacity. And in order to utilize that max capacity, we install several servers on top of a server. In fact, we do this pre-capacity planning in what we call in IT terms. So if a manager comes to you and says, hey, I have 100 people logging into my application right now, and in 6 months from now, I'll have 1,000 people. Can you go buy hardware for me? So in that, his logic is 100 and he wants 1,000. So within 6 months, I have to purchase 10x the server, right? So what we do is, we take a big server and install that application on top of it, so that, we can meet the needs. Yes, auto scaling, we're not going there. Let's keep it to basics, guys. We will go there. We will go to auto scaling. We will go to DR. We'll go to everything. But, for a layman's term, virtualization is something that will create virtual machines out of a physical, hardware. Correct? Now, there are two types of, like we spoke about. First is hypervisor, type 1 hypervisor. See, you have your CPU, you have your RAM, you have your, hard disk and power supply and networking, right? Correct. Now, all of this is in a bare metal server. Correct. Now, that's a physical server. Now, what we do is we install a hypervisor on top of it. There you go, type 1 hypervisor. And once you install that hypervisor on top of it, you have the ability to split them into something called virtual machines. See, guest VM2, guest VM1, and guest VM4. And on top of this VMs, you can install anything that you want. Right? So that's how a type 1 hypervisor works. Now let's look at type 2 hypervisor. So same thing, you have the same set, you have the same set of hardware devices, and you have a bare metal server. And on top of that, you're installing a host operating system. When I say operating system, you can install Linux or Windows, right? And on top of that, you install a software type 2 hypervisor, which gives you the ability to run several VMs on top of it. All right. So you, for example, let's say for type 2 hypervisors, you have you can use it in either Windows, Mac, Linux, right? And some type 2 examples are, you have VirtualBox, you have Virtual PC, VMware Fusion, something similar, so that you can install operating systems on top of it. We're going to demo the type 2 virtualization hypervisor today, and we're going to give you a demo of what happens, how the VM looks. Before going there, any questions? Yes, I think 2 minutes questions should be good. Type 1 is something that you install on top of a server without any operating system installed, correct? And type 2 is hypervisor is something that you install it on top of an operating system, like for example, Windows, Mac, Mac OS, or Linux. So in type 1, you will not install the operating system. You will only install the type 1 hypervisor on top of the server. And in type 2, you install it on top of the operating system. Yes, bare metal system. Bare metal is a physical machine. Each user will be mapped to each VM, or we can give access to multiple. You can do it any way you want. There are several, they are isolated, right? These VMs are isolated except for the network. So you have a management that you have to do in order for the users to access every machine. And yes, that's partly correct. And also you can isolate the VMs. No, you cannot install type 2 on a bare metal system. Type 2 is only on operating systems. All right. Okay. No more questions. Yes. Can we add hard disk RAM? Yes. That's the beauty of it, right? So for type 1 and type 2, you can install RAM, hot swap RAM and hard disks also to the bare metal system. Or the host. You can call it the host and guest. Host is the server, guest is the VMs. Right. All right. Let's talk about storage virtualization now. So you have laptops, you have you have personal computers and everything. So how is how are you that you're accessing the data through something called a hard disk, right? So you have one hard disk and you're using your laptop, and when it's it's close to capacity, either you can do one of two things. One is to either delete the files that you have or to add another hard disk. What Windows does is basically when you add even Linux, for that matter, Linux and Mac, what happens is the extra hard disk that you add will be added to the pool of hard disks that your laptop or your desktop has. It's something called pooling, and the extra space will be visible there. Even with your phones, right? Internal capacity is, let's say, 64 or 32 GB, and you had an SD card on top of it. So what will happen? Your phone's capacity will increase, correct? Similarly, we can do something called storage virtualization. What happens in storage virtualization is you add 10, 20 or 30 disks or storage disks, right? And you can pull them all together and produce one single output or one single storage option. So like it says, right? I mean, you can pull everything in a single device, or you can add multiple devices to to show as a single device. The reason why people do it is on in big organizations, right? You cannot go and install one storage disk per one VM or one machine. So instead, what they do is they combine the power of all the storage, servers that they have into single one, which is called a LUN or however you name it, and then they assign that only that kind of storage to a VM through networking. I know if it goes above your head, don't worry, guys, but think of it as a virtualization for storage devices to add them together to provide the output. Now, there are two types of storage virtualizations that are available. I'll show you what is basically happening here. So you have a physical storage here. So you have two disks or two different storage servers, physical storage. And what you do is you apply a storage virtualization software, and what will happen is both of them will be combined into a virtual storage. And when I say virtual storage, that storage can be attached or detached to VMs within your network or within your organization. The reason being, why do we do it? One is, flexibility. If one disk goes bad, you can always use the second disk, or you can replace the disk using by hot swapping it, or you can utilize that storage to 100 people or 200 people, n number of capacity, or you can use it to provide a greater needs. Because it's highly available. When I say highly available, if one disk goes bad, you can always set up your configuration in such a way that that is available. Your data is not lost. Okay. It's actually a process of combining physical storage, right? From several storage devices. You have 20, 30 hard disks, and they all come in as different storage devices to you. But imagine if you put them all in one server and group them together to have a single storage that's readily available. That's called storage virtualization. Okay. Now there are two types of storage virtualization, guys. One is the block level and the file level. Okay. Block is something where this the data is arranged into blocks. When I say blocks, it is used for the operating system. When I say operating system, the IO, right? Input, output goes through the storage. from the RAM and the CPU, right? So it basically gives the programmers and the programs the data that it requires. For example, save file. You have to save some file in WordPad. You have to save some file somewhere that a program is using. Okay, it basically sends a IO request, input output. So it's sending a bytes data to the CPU and or through RAM. It's sending a request for storing the data and retrieving the data in real time. Okay, so that kind of that kind of IO requires something called a block storage. Block storage, a typical example of your block storage would be your hard disk, your hard drive. That's configured to do a IO operation, and your programs use it. Okay, now there's a file level storage. So it's basically, let's call the file level storage as a data disk, or what is it called? I mean, you call it your storage device, right? Hard disk. What you do is you basically drop in all the items that are not required, that doesn't require an IO operation, that are used for storage. Okay, so it's a file level storage, and the server sees that file level as volumes rather than block storage. When I say volume, it doesn't need an IO operation. You put it there to store and retrieve the files there. I'll give it a pause and see if you guys need something. Okay. Okay. Sure. All right. Okay. So file and block, right? So for file level storage is what is used by your operating system and the programs that are installed in the operating system. So every program that requires an IO operation, IO is input output operation, requires a block level storage. Correct. So when you are utilizing some program, let's say you're playing some games, okay, that games will be stored on a block level storage. That's because there are several computations and data that is being written or retrieved on top of it at a real time level. Even with your word, right? When you start typing something, it's going to automatically save. Where is it saving? In the block level, right? Because constant IO is being read, given out, and taken out or retrieved. That's why you use a block level storage. And block level storage is something that is readily available for the operating system also. So you cannot install an operating system on a file level. You can only install an operating system on a block level. So typically, when you buy a hard disk, when you install a hard disk in your computer, you have this block level storage where it is used for input and output by the operating system and the programs that come from it. Good with the block level? So see, block level usually gets, system detects the block level when you install it. And replication is also available in both of them. So when you format your PC, right? I mean, hard disk, it says FAT32, etc., right? FAT32 is something that's a block level storage. Pratik, good question. There are VMware. I mean, currently in VMware, you can add RAM and hard disk, without switching off the system or the server. At least hard disk part, yes, correct. I know that. Those are called hot swapping. Okay. So for file level, right? What is file level? It's like swapping is nothing but taking the hard disk out and putting the hard disk in, or swapping something with something else. Swapping your iPhone with Android. Swapping your Android with iPhone or iOS. When I say hot, where hot is on, right? When the server is on, we call it hot swapping. When the server is off, we just call it cold swapping. Cold swapping. So yes, Hot swapping is, see, when in typical IT jargon, right? Hot is something when we say hot when the server is on. Cold is when, cold restart, hard restart, or on, I mean, migrations. We use these words. Cold is down, hot is on. Okay, good. Now let's talk about file storage, file level. So, how many of you guys use external hard disk? Like a place where you store photos, pictures, etc. Right? You use Google Drive, correct? What do we use Google Drive for? We use Google Drive to store a pictures, movies, etc., or documents. But we are not installing any application on top of it, correct? It's just used for storage purposes, just for retrieval and storage. Understood? So whereas your system is, you're installing applications on top of it, you're using data on top of it. So the file level is you only use for storage, retrieval, and short request. When I say short request, you have a, we will talk about that, Abhishek. Park your question. Let's talk about this one. Don't talk about something that I have to explain or either I've explained earlier, because it goes flow just gets destroyed. All right, let's talk about file level. So for the file level storage is basically used for storage of large files or small files, documents, etc., where we are only using them for downloads or uploads. When I say downloads or uploads, retrieval and uploading. So this is why we use file level storage. And the reason why we also have a file level storage is because we don't need hard disk with fast RPM or fast through IO for that. That means older hard disks which are less fast, right? Those are not fast, can be used for file level. And why do we use file level? One more example is you have there's an organization, okay, and they install operating systems and they give new PCs, they install laptops and they install OS everywhere, right? So it is not possible for them to physically hold a CD and put it in a hard disk, hard RAM, and put it in a laptop and install everything. So they use something called a storage server. And the storage servers are typically file level storages. That's because they can store huge data, they can retrieve it whenever they want, but they cannot actually run that storage or that file from that particular file server. That's because we are using a file level storage. Now we are good with file and block. I'll explain it one more time if you guys want. All right. Okay, guys. Now, so this is a physical storage, correct? Or a physical storage service. Now, when you install the storage virtualization software on top of it, you have two options. One is the file level storage and the block level storage. And you can convert it basically to either a virtual disk or which is called a block level, or a file level storage, which can be utilized as an external hard disk. So this virtualization can be done to convert these hard disks into whatever type of whatever type of storage that you want. So a storage in an ideal world scenario, you will have hard disks which are some of them are really fast. You call them SSDs. Some of them are really slow hard disks, right? So you can segregate them everything within one pool of storage, and that's the reason why we use a virtualization for storage. So, for example, I need a VM which has Java or any application running on top of it, and it requires fast block storage level, right? Block storage hard disk. So what I can do as a storage administrator is go back into my storage virtualization software, whichever it is, and you can assign it to my hard disk or my VM. You can use that. File level can be used for sharing. That's basically yes, done one of the utilizing for that. Yes. Okay, guys. Now let's jump on to the next one. What is application virtualization? How many of you guys have used virtual desktop? Let's say, in Office 365. No, C level and D drive, both of the things are your block level storage only, because it is attached to hard disk. Virtual disk is a block level storage. I'll show you in the software how it is. Right? So how many, so you guys have used Office 365, right? And Teams also, correct? And in Teams, when you open your mail, right? Are you actually installing any Outlook software on your system? No, correct? Basically, you're not installing on system. What is actually happening is that particular software or that application is installed in some other server. And all you're seeing on your computer is just the face of it. When I say face of it, the display of it, and you're utilizing it, but the load is being applied on top of the server that is installed on. Now let me show you how it works. So you have the server here, and you have the hypervisor. The reason why we are installing hypervisor is to create VMs, correct? So we have VMs. Now, let's say, and you have an application virtualization layer on top of your VMs, and you have an application here. 3 applications, 3 VMs, but single server. Now, and you're clicking Gmail. Everyone use Gmail, correct? Do you think Gmail is a web server? I mean, basically, Gmail is a software, correct? Are you installing it on top of a system? No, but it has to run, right? The application has to run somewhere, correct? So what Google has done is Google has installed that application on top of their servers, but all they're doing is providing us the face. It's like a TV screen. You're just operating it, but your programs are coming from a different source. Correct, right? The software that as you're utilizing in a browser called Gmail is basically installed somewhere else, and that is being transferred to your monitor and a desktop through that virtualization system, right? So application virtualization, nothing but you're virtualizing an application so that it's enabled or given to the end user like you and me, but the load is being transferred or put into the servers back at their servers using virtualization technology. Any questions here? No? All right. So why do we do that? As you know, right, computers are unreliable, not unreliable. I mean, they get old every day, right? Like us, though they perform better, they get old every day. So your grandmother might be using some kind of iPad or something, which is 6 years old or 7 years old. And you might be using iPad, which is new or brand new. But YouTube works, let's take example of YouTube. But YouTube works the same way, right? Yes. So underlying infrastructure is handled by the source provider or the company. So why do we use it? The performance is not degraded. It's easy to install and upgrade, and it's on-demand delivery of applications. And there is no need to install application on end users' computers. So let's see how it works, right? So the server is there. The server is the company's server. Hypervisors is on top of it, and they have VMs. How is it? That VM has an operating system, correct? And on top of that, they're installing application software. And on top of that, they're installing the app that you want, that app that has to be virtualized. Same way. And that app will be given to you in some form of application. Let's say, on like a website or a small application or something. But the heavy hitting is being done on the server itself directly. Any questions, guys? I'll just put this like this. No? We good? So now we are left with something called a network virtualization, which we'll cover tomorrow or day after, because we have 2 classes on network. Okay. So why is it's up to them, right? App 1 is virtualized, app 2 is not virtualized. It's up to them. It's up to us. We have a virtualization app, and we doesn't have, and the same server also has an app that is not virtualized. Yes, me. Any question? Faisal, you have a question. Faisal. All good? Okay, we have 15 minutes more. If you guys don't have any questions, we can probably start installing the software that is required for virtualization, type 2 virtualization. Okay, currently VMware is in the leaderboard. Does Azure provide virtualization capacity? If you're talking about virtualization, Azure is basically giving you virtual machines, right, Pratik? Or whoever asked me, Venkat. And also Azure and VMware have tied up together where VMware servers that are installed on on-premises can be moved to Azure cloud. So that's one of their offering. Application virtualization, yes, that's a separate. See, it's not just software, Sandeep. It's the practices, right? It's how you expose your software, like the use of microservices, etc., etc. Okay, people are joining in. Few more minutes, and I think we can start. So, how many of you actually completed the demo or completed the assignment of how to create a VM? You have done that, just say me. Okay, guys have installed VirtualBox. Let me take that down. Software out. Good. Good job. I'm Sheikh, Manoj. All right. Okay, shall we start or one more minute? I think we can start right now. Okay, guys. Last probably on Tuesday, I said we can install a virtual machine using a virtual box, right? So in order to build a virtual machine, you basically need two things on your computer, right? First one is your OS or operating system. And second one is your virtual box or type 2 virtual hypervisor. Now, the type 2 hypervisor software that we're going to use today is called VirtualBox. So all you have to do is, go to google.com, type VirtualBox, right? And you get this virtualbox.org. Basically, VirtualBox is from Oracle and they've given it for free, right? Click on this. Your page will be different. I have some plugins installed, so that's the reason why it's like this. So once you're in this VirtualBox pay website, you can download it, right? You can go to downloads, click on the downloads on the left side. And by the way, is clarity is fine today? Okay, cool. Yeah, superb. Now let's go to VirtualBox downloads. And depending on what operating system you're looking at, okay. But for me, I'm looking at Windows, right? I'm using Windows. So click on Windows hosts and already have it. When I click download, it will download. So let me download it anyways. I have in my free download manager, right? Let me open that. Okay. I'm just downloading it, guys. Means similarly, you can also download it. Once you download it, it'll open the setup. Correct. Let me show you the setup too. Let me open that VirtualBox software. All right. Okay. So first thing is a setup. Correct. It'll ask us to install the software. I'll show you the part where what is happening here. So if you look at it, what virtual is this fine? Correct? You can see it, right? So you get the custom setup over here. And what it's basically doing is it's actually installing your virtual networks or virtual NIC cards. Look at this: bridge networking, host only networking. This is nothing but it's installing a virtual LAN on top of your computer. So that is what it's doing in order for it to provide internet to the underlying virtual machine. So if you say next, and all, it start creating everything. I'm not going to do that because it's going to reset your network. If you just go to your, for me, this is my Wi-Fi network, right? Correct. Similarly, you'll have a local network or Wi-Fi network. What it will do is it will go ahead, VirtualBox will go ahead and create a virtual network card based on the network card that we already have. Once that's done, okay, all you have to do is now you have to download the operating system. Now let's go to the operating system. Ubuntu is best for us. Let's go to Ubuntu. Click and when you see ubuntu.com, that's the original website. Okay, let's go there. So Ubuntu, you can download it. If you look at this here, when you click on download, you have Ubuntu server and you have Ubuntu desktop and Ubuntu server. If you want to use this virtual machine for the next classes or next upcoming sessions, right? You can always download a Ubuntu server. That's because you're going to use it for networking, or you're going to use it for the Linux basics, Linux commands and all. You can also use desktop if you want to. There is nothing wrong in it, but generally we don't use desktop in the production environments. Desktop is used for home basic purposes. So let's go download Ubuntu server. And it'll ask you, don't worry about this too. I mean, instant Ubuntu VMs, option 3 alternate. We will not going to go there. These are not for now. At least this one is for infrastructure as a service, provisioning and everything. Right now, let's download Ubuntu 22.04. If you think that is too much, you can go for alternative downloads and you can see what downloads you have, 22 LTS or 21, however you want. But make sure you download a server version. Shall I explain it again? Go to google.com, Ubuntu. Yeah, go to Ubuntu link, ubuntu.com. Yeah, it's going to be a little high. Go to download Ubuntu server. Click on get Ubuntu server. And then Ubuntu server 22.04. Click on it and your download should start in some time. And it's already started for me. So I can just click download. Okay. See, I have it already here. Right. So I'm going to close it. So now we are good with downloading part and the VirtualBox part. Downloading, go to ubuntu.com. This is the download thing. I can give it to you in chat, everyone. There's my chat window. Yeah. Right. And VirtualBox also I'll give you. All you have to do is go to VirtualBox, Windows. As soon as you click on Windows, right, it'll start downloading. Thanks, Aparna. All right. Now you got it. Correct. Now, the next thing that we do is actually installing this virtual machine on top of VirtualBox. Now let's go to VirtualBox. There you go. This is don't worry about this. Mine is an older version. You might get this error, or you might, pop up, or you might not get this pop up. Don't worry about it. Okay, yours might be little, probably smaller. I'm going to delete this. Delete all files. Okay. Now I don't have any virtual machines, correct? Now, The first thing that you want to do is add, click on add here. Sorry, not add. Click on new here. What it's going to do is it will basically ask you, hey, you want to create a new virtual machine. What do you want its name to be like? And what is this family, operating system family? When I say operating system family, Windows is one family, Linux is another family, Mac OS is another family. Correct? So let's create a Ubuntu. Ubuntu Nosfer. Right. Now the second thing is it's gonna ask you where to place those hard disk files and the configuration files that come with it. So what will happen is every time you create a virtual machine, it comes with a set of files. One is the configuration file that will tell the hypervisor, hey, this VM's virtual disk is this much, hard disk is this much. This is where it's stored. This is what its networking is. And second would be the page files where it'll block a system memory or system memory, which it's called a page file, right? It will block a system RAM and it will keep it so that your VM can operate. And the third one would be your hard disk files. I'm going very, very, very high level, guys. I'm just explaining it in an oversimplified manner, right? So we have some set of files and it's going to store all the set of files in this folder. That's where your machine folder is. The reason why it saves it over there is, for example, tomorrow you have created your virtual machine in VirtualBox and you want to move it to another server or another laptop, correct? All you can do is you can take this files and put it there in that machine and you can click on the add button here to add the files. Understood? All right. Now type with the Linux. I told you that Linux family. So let's install in Linux and version. What is your version? Fedora, Ubuntu. We don't have Ubuntu here. Yeah, Fedora should be fine in that way. Let it choose it by itself. And now the memory. For my 1 second. So for my for this virtual machine, I'll give it a 4084 RAM. Or in fact, I can bump it up to some 8000 whatever RAM, right? 8192. Because I have basically I have Ubuntu is already there. Yeah. Thank you so much, man. Madhu, I didn't check it. That's okay. So I'll give whatever. I mean, probably 8849 RAM. Okay, just like that. Correct. Now, here are the three options that you get. First is do not add virtual hard disk. Basically, it will not add a storage. Remember, we are talking about blob and file storage. So this is what this VM is using that. Okay. And use an empty virtual hard disk. Remember, I was telling you about saving your hard disk somewhere. You can add it if you have it. But for our purposes, we don't have anything. So let's create a virtual hard disk right now. Okay. And just click on create. Now it'll ask us, how to attach this disk. There are two types of things. One is dynamically attached, dynamically allocated, and fixed size. So what is it? You guys want to understand, right? Let's talk about the storage and the physical disk first, and then we'll go to the hard disk file. Fine. Okay. Now storage in the physical disk part, it's two types. One, if you select 10 GB over here, this is what it's doing, right? When you say dynamically allocated, it'll only allocate some size, for example, 1 GB or 2 GB just for the base system. And it will not actually take all the 10 GB from the underlying host. The reason being, you have selected dynamically allocated. So what will happen is, this is again a type of methodology where the system administrators or the virtualization engineers or administrators use. That's because if you have a storage of 100 GB and you say, he says, I have 5 people and they're all asking for VMs and everyone wants 50 GB. And what they'll do is, since they don't have enough storage, they'll use this option and they'll give it off to everyone. The reason being, not everyone uses that 50 GB in one day, correct? And if you do it like this, all the administrators will get some time to add the storage to their pool. So they do this something called dynamic allocated. This is not memory. Yes, that's correct, Ramarao. But this is the storage. We are talking about storage. We have 100 GB storage. You can, over provision your storage, but without it actually being there. That's also one of the virtualization concept. So what I'm doing is I'm giving my file size as I don't need 5 GB. I mean, I would only need. Don't extract anything. I'll show you. Just wait for that step. Yeah, physical resource. Yes, correct. That's correct. Okay. So I'll have let's say 1 GB to 1.75 GB disk because we'll not use it. Okay. Now the file location. It's basically asking us how to save this file. The reason being, you have VDI, you have VHD, you have VMD, DK, HDD, etc. Right? These are the several several formats that other virtualization software or cloud software uses. So for example, if you have QCOW, right, copy on QCOW, if you select QCOW, you can directly use this machine as a virtual machine in the cloud, in your infrastructure as a cloud. Probably OpenStack will take this one. And then again, we have VMDK, Hyper-V can take these kind of formats to look at. So look at what these formats are, and probably you can understand what they are. Basically, it's like .exe, .inf files, but those format files will be used by different virtualization systems. We are good. We are good there. So you know the difference between dynamically allocated and fixed size. I'll give it a 3 GB just to be safe side. Okay, I'm giving it 3 GB. Next, I'll say create. All right, good. So once I created, it's gonna give me my system over here on the left side, which is my virtual machine. On the right side, you have all of the descriptions. The general thing is, it's an Ubuntu 64-bit system, and the name of the system and the base memory, 7.825 gigs. Giving GB. Okay, that should be good. 7 GB. I'm sorry, my bad. 7,826 is GB, right? I mean, MB to GB, it'll 7.2 GB. And it's going to give the boot order. What happens is when you start a computer, you have that BIOS screen that comes in, right? So what your motherboard does is it will follow a specific pattern of booting. The first pattern when you don't have an operating system is it will always go to the floppy disk. If you have a CD, it will have to go to the CD and the hard disk. But the hard disk, if anything of that doesn't work, for example, it will go to floppy, and the floppy doesn't work, it will go to the second boot order. So here, this is the boot order that your VM machine is following. That my Ubuntu NOS machine is following. And acceleration, see if the para virtualization is on because I've switched it on in the motherboard. And if you look at the display is also part of a virtualization, right? A graphic card, or there has to be something that you have to see, and you pass your keyboard and your mouse strokes to the system, correct? So display is also virtualized. And storage, it's already attached the SATA disk for my virtual machine. It's in .vdi format and it's given a 3 GB hard disk. Audio is there, and network adapter. See if it's look at it. Intel Pro 1000 MT desktop NAT. What it's done is basically it's taken my desktop physical NIC and created a NIC for itself, and it's attaching my computer's network to this virtual machine. And it has a USB controller, and you can also set up a shared folder for you to transfer files from a host machine, that is my machine, to the guest machine, which is a VMware machine, so virtual machine. Now, one more thing is, once you click on this, you can click on settings. And if you go to system, right, there's something called processor over here. Right now, it's only using one CPU. Remember, I was talking to you about my CPU. Let me show you my performance. See, I have 16 core processor, but it's detecting as 30 CPUs. The reason why one CPU is one socket or one core. Core is equal to two virtual CPUs. Remember, I told you in the first class. So if you have a 7 core processor, I think it's going to show you about 16 logical processors or vCPUs. So I have 16 here and I'm at 8%. The reason why I told you virtualization is important is because we don't utilize our system properly. You can see the metrics, right? You're able to see this on the left. All right. Okay, cool. So if you look at it, I'm basically, this is a task manager. Open your task manager, Control Shift Escape. Open it, Control Shift Escape and go to your performance tab and you can look at it. Similarly, my memory is about 64 GB. I'm using, how much am I using? 28 GB. So I have two hard disks. Hard disk is also not being utilized so much. Ethernet, Wi-Fi. I'm not using my Ethernet. So Wi-Fi, see, look at it. This is my actual throughput and output. CPU, if you look at my CPU, these are the statistics that you get when you open your task manager. But what I wanted to show, what I want you to see is, even though consider myself, my computer as a server, so I have about 16 cores. I'm not even using 6% of it right now. I'm not even using 10% of it. So that means if I can share my computer with 9 other people, correct? So that's a big win for me. I can even take money, right? That's how cloud is working right now. You pay as you go. You pay for the consumption. And in order for me to split my computer into 9 halves, nine different partitions, I have to use a virtualization software. So that is what I'm doing right now. I'm creating a virtual machine and I'm giving it, see, out of 32 cores, I'm going to give it 6 cores. Okay. Acceleration, you can leave it default. These are the things that we'll not need right now. And go to storage. No, let's and click OK. Go to system. Processor, you can give 2. Guys, don't give more than 2. More than 2 maximum. 2 or 3. If you have a big i7 system, give 3 maximum. I have a beefy computer, so I'm giving it 6 for the purpose of this demo. Otherwise, it's going to take some time for the system to start. All right. So and press OK. Now the first error that I'll get when I start is, can anyone guess? Okay. Yes. Why is that? Not the BIOS you guys are already fixed. Correct. So it's saying I don't have a disk to start, guys. I mean, I don't have an operating system. I don't have an operating system. It's like put an operating system and I'll be happy to start. So let's select from here. Since I already have it, I'm not going to add that. I'm going to go close this, right? Power off. Go to go to settings and go to the storage over here and click on the empty controller ID. This is your CD drive. And I'm going to use Ubuntu. What did we download? This one, right? Choose from a disk. Disks. Yeah. D software. Yeah. Now software, we have it. I'll open it and I've added it. Correct. I have a Windows too. Let's try how that works once this is done. So I put the ISO image. I'll say okay. And the next thing that I do is, just start my virtual machine. So it's like try or install. You can now. Okay. Let's do that steps again for ISO. I'm going to show you once again. I'm going to control escape or control V. 1 second. Okay, even if I machine, okay, fine. I think I'll show you. I'll basically show you the view. Can you see it now? Yeah, we'll check that, Mahesh. Mahesh, I don't know, full name doesn't come there. So what is happening basically? It's installing the virtual machine, and if you full screen it, right, you don't even know if you're in your machine or your virtual machine. Correct. So this is how you install. I'll also show you how to put the CD in again. What was that? Okay, so that's how, while that's happening. Okay, now it's asking me to choose the language. I'll choose English. Done. Ask me Ubuntu server. I can just check this. See what it's doing here. It's actually setting up a network interface card. The networking that this Ubuntu needs, right? It's setting up. I'll just press done with it, and we don't need any proxy. We don't need anything else. Just press OK. You guys are able to watch my screen, right? Okay. Okay. All right. So it's basically doing. Haridas, just ask questions pertaining to the class only. When if you have technical issues or if you have anything about uh, you know uh, the course and all, please talk in the WhatsApp class. This is not the place and forum to discuss these things. Okay, since I've not given a proper storage to this, right? I mean, I've given 3 GB. Probably it was not enough. So it's giving me an error. Do you guys know how to come out of the screen? Did you guys actually watch it? Do we need to install only Windows virtual machine? No, you can install anything that you guys want. It's not just if you want Windows, you can use anything that you want. All right. So it's throwing me an error, guys. The reason being, I think I've installed less, I've put in less hard disk. So we can change that. Yes, that's Control Alt, correct. So if you're inside it, press Control Alt. So what I'm doing here is I'm getting an error with the storage. That's because I've given it only 3 GB. Okay. I can either add a new one or remove it and restart new one. You're getting it right. So remember, when I was installing this virtual machine, I put only 2 or 3 GB as a hard disk. So it's throwing an error. So what I'm doing is I'm going to my setting. I'm going to the storage. This is the hard disk. Remember, Ubuntu Nosfer is the hard disk. I can see, look at this 3 GB. I can either add a new one or remove it and create a new one again. Right? So you can either create NVMe or something, but right now, you can create default. But again, I think it's going to throw error because we screwed up with the storage. All right. You're getting where I made mistake, right? Okay. So basically, I have not been given a storage, so I have to start a new use an existing disk. I'm trying to create a new one here because that storage is not available, right? Yeah. Ten GB is fine now. So this one is the old one. I have not given a proper disk here. So if you look at this, that's the old one, and the new one, we have added a 10 GB disk here. Got it? So if you want to add an old disk to the old one, if you want to change it, you can add a thing. Is SATA, right? Type can be anything. And here, I think you have to add the virtual disk here. Okay, we don't have anything. So Ubuntu Nosfer is a disk that we have. You guys are getting what I'm doing? So I've deleted my hard disk, correct? So you're adding new storage again. So what you have to do is in order for you to have a storage, you need to have the interface first. For example, in a physical hard laptop, even if you have a hard disk, there has to be a cable that connects to a system, correct? Similar way, I'm adding an interface called AXE SATA. SATA is what we use, right? SATA disk, SATA cable. So cable is there. See, it's even giving the cable symbol over here. Now it's saying, hey, I have the cable connected to the system. Give me the hard disk. So I'm clicking on the hard disk symbol over here. So here I have only these two. Ubuntu V2 is the new thing that I attached, and this one is the old one. Remember, 3 GB is the first thing that I've done. So I can add this, or I can create a new one. And when I'm creating new one, it's asking me next. Same thing, I'm dynamically allocated, and I'm giving it 10 GB this time. Okay, create it. Now this one I'm adding. So see, my hard disk is now attached. And if I go here to Nosfer again and start it back, this time hopefully we will not get any issues. Okay, let me do it in scaled mode. Just okay, you want ISO step again? Fine, 1 second. I'll just power off this. I'll show you once again how to show the ISO. So version 2 is the one that I've recently started, correct? Go to settings and go to storage and go to controller IDE, right? Controller IDE. Go to empty and click on this icon over here. This is basically a CD-ROM. So click on it. It's gonna show what you have. If you don't have it, you can choose a disk file and it will go to the your Windows directory where you have downloaded it. Click on this, download that ISO. Once you've downloaded the ISO, click on this and click open. Correct? Now you're getting it? Everyone's clear? Go to your storage, go to your controller, click on the CD-ROM, click on this icon. If you have it here, that's fine. Otherwise, choose a disk. Cool. Now good. Now, where are we? Yeah. Let's start our old machine. Click on the virtual machine, Ubuntu Nosfer or anything, and click on start. So I'm just seeing if the thing works. If you have any questions, yeah, put down over here right now. So it's going to take a little bit time. And for Mac virtualization, you cannot, there are hacks that you can do. Yes, installation is happening. Ubuntu system is getting installed right now. A virtual machine is being created. Operating system is being installed on top of it. For Mac, right, you guys have something called Hackintosh, I guess. I am not sure if there are ways for you to start a Mac VM also, but they are very unreliable and I don't think they're going to work in any kind of production environment. But on the other way around, You can install a Windows virtual machine in Mac operating system, but not the other way around. For Mac and Windows, it's very, very hard, but it's not, it's possible. Okay. So Hackintosh is the word that you're looking for. Someone asked me on it for it on WhatsApp. Yes. Don't give any proxy. You don't have to give any proxy. Just press enter. This is the hypervisor. Your Oracle VirtualBox Manager is your hypervisor software. So this video will be uploaded. Guys, let's finish it today. Whoever has not completed. If you don't have the laptop, that's fine. Try to borrow someone's laptop, your friend's laptop, and just do it. If you just watch the videos now, you will not be able to progress properly. What type of programs you mean? VirtualBox or VMs? You can run anything you want. Basically, you're on Windows, right? You want to develop something on Linux. You can quickly create a Linux machine and start. What's wrong with this? Do we have to restart? We are doing, how are we doing? We are doing 20. Wait, we have given 10 GB disk space for the VM, right? 10 GB. No, it will not be blocked until you select that create a hard disk now or something. There's an option, right? If you put dynamically, grow and shrink, then it will not be blocked. Yeah, there's an error. Let's see. Yeah, there you go. It started. Okay, video size is good, or you want me to increase? Let me increase it. Yeah, 10 GB will work. I mean, see, we all make mistakes and we'll all learn from it. Today, you've seen my mistake and I've learned from it, and you guys know now. Give proper sizes to your VMs. Don't be arrogant like me and use a little bit or conjuice. Give proper VM sizes, guys. It'll work. Yeah, if you want to use entire disk, use it or dynamically provision it, and however you want to work on it, that shouldn't be a problem. If you have enough hard disk space, use it. Okay. Meanwhile, shall we try out Windows while this happens? I don't know when I downloaded that, but I'll still try for you guys just to show you how the process works. Okay, I'll just minimize this so we can see the preview anytime we want. It's happening. Okay, now let's create a Windows machine. What Windows is it? I don't know. For Windows, I think we need at least how much do you need? Okay. 8192. Okay, create a hard disk now. Create, and yeah, 30 GB is fine. Let's give it 50 probably. Create. Okay, the first part is done. The template is created. Well, what is happening here? That's the same thing. All right, I think it's working. Okay. Anyways, now that Windows virtual machine has been created, let's go to our settings again. System, give it at least 4 CPUs or 8 CPUs. In our case, I'm using and storage may empty. I have a Windows 10. Okay, system Windows 10. I have Windows 10. Okay. Okay, that's interesting. Is it 32-bit or so? What I'm doing is I'm checking what my version is. Windows 10, 64-bit. So in general, I can go for 64-bit. So I have display, everything configured, monitor, one monitor, everything is done. Storage is good. So let's click on OK. Let's see if it's starting or not. So see, I'm using my system as my computer as a host. I'm basically right now running two virtual machines, correct? One is this one. Another one's Windows. Yay, see, we got the boot screen. So that's how you start a virtual machine. That's how you create a virtual machine. So you just have to restart it. Don't remember it taking so long. No, it's up to you. You can launch one or two or three. For the sake of this demo, I'm actually putting, I'm just creating two. Both will work parallelly. No problem with that because my underlying system has a proper hardware to, ensure that the VMs are running. Look at it. Two systems are running. One, two. I can even start this just for the sake of it. Okay. Okay. Yeah. See, I'm starting three virtual machines now. Windows, it's just it's like this. Got it? So similarly, even if I don't have an operating system, correct, on top of my bare metal server, you install a hypervisor type 1 hypervisor and start creating VMs, right? So that is the use of virtualization. And tomorrow, let's say in the future, when you use clouds, right? This is how Windows is. This is how the virtual machines are installed or created in the backend. And what you're being given is the screen, basically not the screen, credentials of your system. And the way you log in is either using a remote desktop or a SSH connection using the network. See, I'm actually installing one more Ubuntu. See, actually, the second Ubuntu system that I started, right, is working. I mean, better than the first one. Okay, that's on its way. And what's happening with Windows? So I right now have three virtual machines that are going on simultaneously on my hardware. Understood? You want to see Windows from the first? Yes, you can add that. You can add. Okay. Let's see. I'm going to close this Windows machine. Okay. And I'm going to show you how I created Windows. Okay. Power off this machine. Now the system is powered off. Let Ubuntu work in the background. Now I have this. If you want to delete this, right? Click on this. Click on your Windows or any virtual machine, and you can remove it. And it will ask you for delete all files or remove only. So when you don't need the files and when you don't need the hard disk, you can just delete all files, and that's gone. So see, I'll show you how to create a new Windows machine again. New Windows 10. Okay. Version is 10, 64-bit. Memory size is let's say 8192 is fine. Okay, this is fine. Now I'm creating a new virtual machine. By the way, you might get like something like this, right? So I put an expert mode so you know what is happening. Windows. And create. It'll ask me for hard disk. I'm creating a hard disk, dynamically allocated or fixed size. I can put dynamically allocated and click on create. Once that's created, switch, go to your Windows system, go to settings, and then go to your storage. Now you have the CD icon, right? You guys know what CD is? I mean, hope you're old enough like me. You know what CDs are, right? So click on CD, the CD icon or optical drive, and click on this. I have my Windows already downloaded from, I don't know when we downloaded that, but I have it. So when you click on, it will be downloaded in your download folder or wherever folder, whichever folder you've actually set in Windows as you download. So in order for you to get this Windows, you have to go to Microsoft website and get it there. Yeah, I have it downloaded. Nothing over here is, you will not get all of this. You'll only get probably Ubuntu if you've tried it. That's because you've already downloaded it and added to VMware, VMbox one, VirtualBox once. So you will just have to go click on this one. Click on your choose a disk file and go to your Windows Explorer and then put it. Then go to the file where you have downloaded Windows and start Windows. Got it? You will not be having it here. I had it here. I have it here because I've downloaded it sometime. I don't know when. Probably for the demo, I must have downloaded it. Yes. Yes, yes, correct. That's correct. You have to download Windows OS or any, like you downloaded Ubuntu. Same way you download Windows. If you want to download some other version of Linux, download it and start the VM. Well, still installing or Windows, Microsoft. The first version is stuck. That's okay. Okay, now you got it. Now you understood how to do this. So all of this is automated when you do it in the cloud. When I say automated, you will be getting a front-end dashboard, Azure or AWS or GCP. All of this is automated. This is all the under cloud stuff. So when you create a VM in the cloud, all of this is happening inside a server under a hypervisor or virtualization. And that's the reason why you need to know what virtualization is. If you want to understand, cloud better or your progress better. Got it? So this is what's happening underneath. So you see, my system only could run at least three, 4 VMs, correct? Imagine the servers that they have. Unmounted. So what happens is, once you've installed Ubuntu, similarly with everything, once you've installed an operating system, when you restart the system, remember the boot options I spoke about? The boot option will go to the CD first. So only when you unmount the CD, it will go to the operating system, correct? So the CD, once you installed it, or the optical or the drive has to be removed. So the VM creation and all this, it's called the ISOs, right? You can do that. I mean, once you install everything, there are some tools that you can use to make your own CD. How did you mount it? The same way you unmount it. So Ubuntu is running, right? Let's go to Ubuntu Nosfer. Click on settings. Once the installation is complete, go to storage. You have this Ubuntu server over here, right? Click on this and you can remove the disk from virtual machine or unmount it. My second virtual machine I've started at last. Now you know how to unmount it also. See, block device. Installer is waiting for block devices. What is a block device, guys, for us? Yes. What is a block device? Name it. Remember, we spoke about it. Correct. Exactly. And what is a file mount? What do we do for other one? Block, and what is other thing? Not network files here. Give the proper name. Continue. There you go. Yeah, file storage, block storage. Some people also call it blob storage, but don't get worried. File and blob are the same. Right now, you know how to run a virtual machine, how to set up a virtual machine, and how to delete a virtual machine. Any more doubts? So once a virtual machine is created, it will say that you have to unmount the CD or unmount the OS. To unmount, the same way you mounted the ISO, the same way you have to unmount it. Go back to your settings and go back to your storage. Go back to the controller optical drive and click on it and remove it from this and start the system again. We have two systems running. Hope you're able to see everything today. I mean, not like last time, correct? If you're stuck inside your virtual machine, Control and Alt gets your cursor out. Any questions? Good with today's class? So do you think this demo helped? Yeah, same process for cloud, but actually you will not be doing this. The people at Microsoft, Google, or AWS will be doing it for you. You don't have to worry about any problems. It's their issue, and they'll give the VM that you requested for. Yeah, you can create how many ever users you want, not one or two. Yeah, I'm hoping to see if this process completes fast. I mean, I don't know. I have the biggest system here and it's slowest here. We will not be doing that, Surya. You go ahead and see the Linux commands. When we get to Linux, we will show you how to create users and the 2025 basic commands. But there are many tutorials available online. All you just go to Google, search for create user Linux, and or the whichever you're using Ubuntu. Add user something. Not hard, just 2 minutes job. That's it. All right. Tomorrow we will start Azure Basics, Introduction to Azure. Very small basic introduction to Azure. Recap what is fault tolerance, high availability, elasticity. And then we'll start what Azure is and where it's and its infrastructure and organization. Then we'll talk a little bit about Azure services and how you can utilize them. And I think we can conclude what the basics of Azure, I mean, the introduction to Azure. From Monday, we are planning to go ahead with AZ 900, right? That will be 1 week to 10 days long, 1 week to 10 days long. And after that, we'll be going through AZ 104. It's important you guys don't create any Azure accounts right now. Let's buy ourselves the maximum times. And one more things, guys. If you want to create an Azure, Yeah, let me 1 second. We'll talk. So if you want to create Azure accounts, right? You guys have to have either a debit card or a credit card, and international transaction has to be enabled. They'll charge 1 or 2 rupees and give that money back to you, and they'll give you a free account, free tier account for 1 month, where you will not be charged for the services that they give you. Okay, be ready with that next week. Otherwise, you will face issues creating Azure accounts, because recently Government of India has introduced some auto debit facility, etc. Some law they have passed. So after that, creating Azure account has become a mess. So be ready with your credit or debit cards. Not for me, for yourself when you create Azure account, but make sure that you guys have this transaction enabled. I don't think they are using they yeah yeah for Azure. I don't think one card can give two portals. It's stupid. I know Microsoft becomes very stupid sometimes, but yeah, yes, it's a lifetime Azure account. You have to pay for the services that you use. That's correct. Or use someone else's card, your mom's card, your dad's card, husband's card, wife's card. Take a card. Tell them, I'll use 100 rupees today. Okay. Aparna, would you want to discuss the hack with us? Probably you should take one session for us. So partition issues, who was sending me an issue? Yeah, like me. Yeah, you can directly talk to Ravi or me myself. That should be okay after the class. Okay, installation complete on the second system. Look at it, guys. Now, once you reboot it, see, I'll get the same error. Yeah, finally, right? All right. So installation is complete. Everything is done. It's running. It's stopping. No problem. I can just. Other one is also finished. Is it? The other one. It's installing the kernel. Okay. It's powering off the system. Now, when I start. Okay, not this. When I start it. That's okay. When I started, I think it's going. Hopefully, it should ask me for the. See, it's going back to this again. The reason is I didn't switch it properly, but I should be getting a warning saying, your optical drive is still in. Okay, when you get that, all you have to do is go to the setting of that virtual machine, go to the storage, click on the image that you have downloaded, go to the CD icon over here, and remove this from virtual machine. So it will become empty again. So for a new VM, add it. For an old VM, remove it. All right. Any more questions for today? Guessing no. Or am I missing something? Oh, you guys. Okay. Don't do it like me. That's the proper way. You can turn it off. There are. Let me show you. Excuse me. You can either do it like this, close. Okay, or you can go there to your virtual box and do it. Okay. See, reset and close. Reset is restart, close, and you can shut it down. My screen is not visible. I'm sharing my screen. You can shut it down. It's fine, no problem. Once you're done with your work, you can just click on it and, close and power it off. There's something called a save state, which I forgot to tell you. If everyone's here, how many people are? All right, okay. Quickly, I'm saying when you press and close, right? If you say save state, the VM will just freeze. So next time when you start, you can start it at the way that way that you froze it. But if you say save state, right, your CPU, your resources will be utilized, or they'll still be under use. We can talk about it tomorrow if you guys have any doubt. But I don't think you guys need to know this. But anyways, just power it down if you don't want to use the VM, or you can just click it like this. Power off your VM. Okay, guys, thank you so much for attending today. As usual, if you have any doubts, post them in the forum, and please do share and like our social handles also. So that gives us a visibility, right? We also want to start future batches, so please do that. Okay. Okay, I'm opening mic if you guys want to talk something. So, okay. Okay, there you go.
Okay, there you go.
1 second.
Yeah, Sandeep, no.
Yeah, tell me, who is this?
Yeah, tell me, who's this? Yeah, Sandeep Naresh here. Hello?
Yeah, it's good.
Yeah, no, it's good. Yeah. Sandeep, so we installed the VM, right? Getting some background noise. Yes, Sandeep. So once we install this VM, right? Suppose on top of this VM, so I have installed some softwares like Tomcat, some other tools. So suppose, and on top of that, the company is having some 100 VMs. So we can't install all the things in all the VMs, right, at a time. So for that purpose, we'll be creating an image on top of this, and we can use the image for all the VM creations, right? So
Yeah,
you know
that is
that
one
process,
way.
like how we can do that. Yeah.
One way. Yeah, that's one way, and
Yeah,
you
that's
can
one way,
further
and you
simplify
can
this process
further
by
simplify this
installing your
process
patch
by
manager
installing
or
your patch
something like
manager or something like
there's a Windows tool,
there's a
Windows
Windows
Update Manager
tool,
or
Windows
something like that.
Update Manager or something like that. So,
Or yeah, wait. So
or
understood.
yeah, wait.
So you
So
can
understood.
install
So
like
you can
100 or 20
install like
software that you
100 or
need
20
in
software that you
one
need
VM,
in one VM,
right?
right?
And you can create a
And you
disk
can
out of it.
create a disk out of it.
So next time when you're
So next
creating
time when you're
new
creating
VMs, you can
new VMs, you
simply
can
use this
simply
disk for
use
all
this
the
disk
VMs.
for all the VMs. Okay, got it. You mean to say like, so on disk we need to install all the things, and whenever we are creating the new VM, so we need to attach the disk to that VM.
Yeah,
Point
that's
is right?
called a
That's
golden
called a
disk.
golden disk. Okay, got it. And like, so see, now we have a VM, right? Now Ubuntu we created. So on top of this, can we create our own image? Own ISO file.
Yeah, you can create.
Yeah, you can create. Okay. Actually, I don't know the process how we can create that, but
Yeah, there are a lot
there
of
are a lot of
ISO
ISO
creators on Google.
creators
You
on
can use
Google.
any one
You
of
can use
them,
any
and
one
you
of
will be
them,
able to
and you
create
will be able to
ISO
create
image out of it.
ISO image out
Yeah,
of it.
Sandeep, your voice is
Sandeep, your
getting
voice is
echoed.
getting echoed.
That's because someone
That's
has switched
because
on the
someone has
mic
switched on the mic
and
and
speaker somewhere else.
speaker somewhere else.
Is it better? Yeah. So basically, my narrator started this mic, right? So my voice is being echoing there. That's it.
And like you had asked to go to the social media, which we went. You also had asked to rate your lessons, but where do we go and rate?
You mean I just want you guys to like and share. I will share the handles probably periodically.
Yes, I was talking about
Going
the handles
forward.
because I went to the social media, FB and all, and I've already liked the pages.
Yeah,
But
website
I
is
didn't
half
have-
baked right now. We have to cook it as we go further.
No, no,
Yeah.
no.
Yeah. So let's coming
FB
back. So
saw,
like what are the
Facebook.
different
Yeah, yeah.
computer? What are the different
There
components
We'll
which
do
are
should
that.
like
work
the
together
We'll start
for
promoting
a
you,
those.
computer
but
to
I
perform
remember you
operations?
said that
So obviously
even the
the first thing
lessons
is
to
the first
rate
and
the
foremost thing
lessons. So where do I
we
go
have to
to
have is
rate
the
the lessons?
CPU,
Was my
and
question.
like all the hardware
You mean
devices and the software like
what the lessons
peripheral
you want?
devices need
You
to
want to watch the lessons,
work
right?
together
Those
to
will be in
perform
No,
the
no, no, no,
computer
no.
to
Hold
operate
on, hold on, hold on.
Aparna, you can
perform
rate our
operations.
rate the course on our
Oh, you mean
website.
rate
So
the
First and
lessons?
foremost
Okay,
thing we will have is
okay,
the
got it.
CPU,
Yeah, sorry,
Yeah,
my
and
mic
next
was
we'll be
low. I
having like
just increased the
different
volume.
hardware
Yeah,
things
so
like
rate
motherboard,
rate
memory,
the
hard
lessons or
disk,
rate your
network
whatever.
card.
Yeah.
So all these
yeah. I
components
So where
think
do
together
I
we
go?
call
in
it
the
as a computer.
courses, I think you can rate there. If not, I
Oh,
can
okay.
take a
But
seat
then
and
I thought it is like
So
then it
why
is
is the
private
name?
to
Why
me,
is
right?
the
It's
name?
not
Is
public.
it's named as cloud?
got it.
So the cloud
Yeah,
came
that
from the
was the
network
reason I was
design that
asking
was used
what
by
could be.
engineers.
Okay.
So like the network
For now,
engineers, like
I
which
will
who are
go.
working on different
Thank you.
All
locations
right.
on
Thank you so
various
much.
network devices,
Anything?
Welcome.
when
Anything
they are
else?
when they are doing the interconnections and when they are doing the architecture topologies,
No.
every time like they look
Okay.
the network
Then have
architecture
a good day,
topology
everyone,
looks like
and
the
see you
cloud symbol.
tomorrow.
So since the symbol looks like the cloud, it has been named as a cloud, and then the the shape of the network design is also like cloud. So where did the cloud come from? So in the 1960s, so like when the internet like ARPANET project has been taken and the internet was getting designed, their flowchart symbols like whatever the flowcharts that they have like that the in that the ARPANET project is taking care of. So all these flowcharts are looking like a cloud. And in the late 1980s and early 1990s, when we are installing the software onto the computer using the floppy disk, we need to insert the disk onto the computer. We need to install that particular software, and we need to remove the software, and we cannot restart the computer until the that particular software is got installed and all. And so to solve all those problems and look to serve the infrastructure cost like the capital expense and the operational expense, so the cloud has originated. So as of today, like we have like many cloud vendors such as like Azure, like which is provided by the Microsoft. We have Google Cloud Platform, which is provided by the Google Cloud, and we have the Amazon Web Services. Like Amazon is providing those services. So in the same way, like we have multiple cloud vendors today. So basically, what is cloud computing? Cloud computing is basically like the readily available servers or the services which we can fly or which we can start on demand on the fly. So for example, if I need a server in the earlier days, like when we used to have the on-premises infrastructure, if I want to host a new server or if I want to host a new application, first I need to buy the physical hardware. Then we need to set up the server on that physical hardware, and then we need to host the application in it. So it would take like around like 2 to 3 weeks for setting up a single application. So now after virtualization has taken place, taken place the on-premises infrastructure, we would have we have created the server or they created the instance from the physical hardware on top of the physical hardware as we discussed yesterday. And when this cloud computing comes in, so these services like we have the servers and services, everything set up early, set up at first, and then like based on the demand, we can fly up the or we can spin up the services or the servers on the fly. So for example, if I want a server like if I want to host an application, we just need to like, I just need to spin up the server on the cloud environment, which would hardly take around 3 to 5 minutes, and I can spin and like I can use the server however I need, like, in which way I need. So what is the what are the disadvantages, like what are the struggles that we face during the like when we use the on-prem infrastructure? So basically the first thing is the expenses. So it's like we need to have the high investment for the on-premises infrastructure. So we need to buy the physical hardware. We need to have a separate server room. We need to maintain the coolants in the data center. We need to have the maintenance person 24/7. We need to do the maintenance in regular intervals. So all these will cost us more. So basically, like if we use the on-prem infrastructure, the investment is very high. And even after taking care of all these maintenance activities and all, we face the scalability issues. So like on-premises infrastructure are not easily scalable. So if we want to like if a scalability in the sense like if we want to add one more server or if we want to put an application under the load balancing, we again need to create the new server from the scratch. So which would take a lot of time. Also, it would consume like it will consumption, the energy consumption is very high. So we need to maintain the coolant like for setting up the coolants or for setting up the hardware systems or for like the power usage, everything is high. And also we need to maintain the hardware, separate teams for hardware and software maintenance, and those teams should be available 24/7. And the implementation times is also very high, whereas like the physical repairs here are a lot, and like 'cause most of the times we may not get the spare parts that can be replaced. So that would be a blocker for the application or for the blocker for the server. So we cannot afford to down the application or down the server for such a huge times. So again, like we need to have get the server from the scratch. So like there are a lot of issues with the on premises infrastructure. So to overcome this, we have come up with like the cloud infrastructure has come in and it has solved most of the problems. So in the cloud infrastructure, the main biggest advantage is like we will pay only for what we have used. So for example, if we have a server in on-premises infrastructure with 8 GB of RAM and 500 GB of uh, hard disk, and that server utilization is hardly like we are using only 2 GB of RAM and like 100 GB of hard disk. So remaining 6 GB of RAM and the 400 GB of hard disk is getting wasted since we have already paid for it. So we cannot roll back it. Whereas in the cloud infrastructure, we can pay only for what we have used. So for example, if I have server or like if I have a server like with 8 GB of RAM and 500 GB of hard disk, only 2 GB of RAM and 100 GB of hard disk is getting utilized. We will pay only for what we have used and only for the uptime of the server. So, for example, if I don't need a server to be running 24/7, I need to I can log up the server every day at 6 p.m. and I can log in again at 9 a.m. every day. Like basically, like, I need the server to be running only during the business hours. So I can set it up like the conditions or the alerts or the run books to switch off the to turn off the server every day like after the specified time. So the charges for the server, like we will be paying only for how many hours we have used, not for the excessive things. And we don't need any physical space to set up the servers or for the hardware, because all the hardware or all the physical servers has been taken by the cloud providers. So for example, if we are using the Azure cloud, the physical hardware and the physical servers on the space, the data center maintenance, coolants, everything will be taken care by the Microsoft. And like we don't need to worry about the updates and maintenance of the infrastructure. And using the cloud, the deployments are very fast and they are very quick. So we can spin up the instance or we can deploy the application within no time. Moreover, we can access the data or we can access the resources from anywhere in the internet. So is this clear till now? Or like, if you have any doubts, you can just shoot it. Okay, thank you. So the main pillars, like the cloud service offerings, like we have three types of cloud service offerings, which are the main pillars of any cloud. So it's not the same for like it's not only for the Azure cloud, it's not only for the Google cloud. So these pillars or these offerings are same for every cloud, or it's across the cloud. So those are software as a service, platform as a service, and infrastructure as a service. So as the name indicates, we are So, as the name indicates, infrastructure as a service uh, is the infrastructure is has been provided as a service by the cloud vendors. So, in how the infrastructure as a service works? So, infrastructure as a service is the virtualized IT infrastructure, which is where the physical infrastructure is completely taken care by the service provider. And on top of the physical infrastructure that are provided by the service provider, we just install we just install the virtual softwares or the virtual applications on top of that physical infrastructure. So services are provided to the cloud administrator to build cloud infrastructure on top of them. So with the service, like the physical servers, like the physical hardware are being provided as a service in the cloud computing, where by using all those services we will be creating the infrastructure. So it can be the data, it can be the storage, or it can be the servers, or it can be the networking components, or it can be the virtualization, or it can be the maintenance. So everything will be taken, like the infrastructure maintenance will be completely taken care by the vendors itself. So whatever we are building on top of that physical infrastructure is our responsibility. So for example, if we are spinning up a server on top of the physical infrastructure, so that's the maintenance of that particular virtual server or the virtual machine is our responsibility. So like taking care, like maintaining that particular virtual machine, or like deploying the applications into that virtual machine, or like providing access to that virtual machine is our responsibility. So since like service provider like Microsoft Azure is providing the physical infrastructure or the physical hardware as a service, we on top of where like using that service we can create the infrastructure. So it is named as the infrastructure as a service. So in the same way, we have platform as a service, where for creating the applications or for deploying the applications or for performing the batch jobs or for parallel processings. So we don't need any underlying servers. So PA platform as a service is completely serverless computing, where all the physical infrastructure has been taken care by the uh, service provider, and we just take that physical infrastructure as a service, and we deploy our applications on top of that physical infrastructure. So it's a platform provided by the service provider with all the tools that are needed for the application to run. So for example, if we are deploying any Java based, or if we want to perform or if we want to run any Java based application, we don't need to worry about like deploying the virtual machine or installing the Java version, like the specified Java version into it and all. So we just will deploy the application onto the platform, and the service provider will take care of all the maintenance, all the installations for that particular application. So the programming language, operating system, server, database, everything is taken care by the service provider, and it like they all like service providers will manage and maintain them. So our only job is to we just need to compile and build the application, build and deploy the applications on top of the physical infrastructure using this platform as a service. So this is mostly useful for for the developers, where they want to test the code or deploy the code onto the production or to the development environments after the application is developed. So next one we have is a software as a service. So software as a service is basically the services that are the software that is hosted as a, that is provided as a service. So for example, so today we are using the Gmail application or the Outlook application, where like we don't install the on like infrastructure on our machines, or like we don't install the servers on our machines for the mail for to access the mail. So we just configure the mail in our laptops or in our mobiles or in our devices, and that mail will be connected to the exchange server or to the Google server, where like it is hosted on the virtual infrastructure, and we are not even aware of like where that particular server is hosted. So in the same way, we have the SharePoint, like where we access the applications from the virtual environment, where we can save all our documents, or we can access the documents, or we can edit the documents and all. In the same way, like we have these Google Documents, Google Images, Gmail. So everything, all this will come under as a software as a service. So basically, in this software as a service, the core application is hosted by the company. So whichever company that is offering that particular service, that is hosted by the company on the cloud environment, and end users will not have any control over the functionality. So end users will have only access for will have control only for accessing the accessing the service. So whatever the company is providing, like only that can be used by the end users, and it is basically an independent platform. So all these services, like all these softwares which are provided as service, we will be accessing over the internet. So in the real time example, if we see about like infrastructure as a service, so own car, like whatever the car that we own is the real time example of the infrastructure as a service. So here, if we want to own a car, or if we want to buy a car, we don't need to manufacture the car. So some other car company is probably is manufacturing it, and we are just purchasing it. So the car, like whenever we are buying the car, like the car is like a company is manufacturing the car, and once we buy it, we take care of the maintenance of the car. So it can be like filling the fuel, or it can be like service maintenance, or it can be the driving, or it can be the repairs, damage repairs and all. So everything will be taken care by us after we buy the car. So here, a car, if we consider the car as an infrastructure, so that particular infrastructure is provided by the service vendor or the service provider, and the maintenance of that particular infrastructure will be taken care of us. Thus, as the same way that like once the car is provided by the company, and like we are responsible for maintenance of that particular car. So this is the real time example of infrastructure as a service. Next, we have the platform as a service, where we can consider the Zoom app or the Rev app as the Zoom car, like or the as a real-time example. So in this way, in this scenario, the car and the maintenance are owned by a different company, like are owned by a third-party company, where where the whole car will come as a service. The fuel maintenance, or the damage repairs, or the maintenance of the car, service maintenance, everything will be taken care by the company, and we just need to procure the car, and like we can drive the car. So everything is taken care by the company, and but we just need to and we just use that particular car. So it is similar to the platform as a service, where everything will be taken care by the service provider, and we just use that platform to run to run, build, and deploy our applications on that platform. So next we have is the software as a service, where we can take the real time examples as Uber, Volo, and Rapido, etc. So here here we no need to drive the car as well. So the driver comes in with the car, uh, the whole package has been provided as a service, and we just use the service. We don't know like where the car, who is the owner of the car, and who is the driver, and who is taking care of the maintenance of the car. So we don't know any details, but we just use that particular service. So here the services that are provided by Ola and Uber are used by the people, right? So in the same way, like the services will be provided by the company, and and the end users will just use that particular service. So in the same way, like under in the software as a service, the software is provided as a package, and the end users can only use it without knowing like the other any other details about that particular software, like where it is being hosted, or like who is maintaining it, who is controlling it, who is deploying it. So we don't know any other details, and we just use that particular software. So I will just take a pause here, and like you can shoot out the questions if you have any.
Can you please update about what is the platform as a services once again?
Okay, so platform as a service is basically is what is like. So we have the uh, if we want to deploy any Java based applications or any Python based applications in the during the on premises time, we have for deploying that particular application, we have to host the server, we have to install the that specified Java component, the compared we have to take care of the compatibility issues, and then we have to run that particular application in the server that we have created. Whereas in now in the platform as a service, we don't need to create any server. It will we don't need to create any server, we don't need to install any specified components, or we don't need to take care of any compatibility issues. Then we can just deploy the application on the underlying core infrastructure that is provided by the service provider. So we just use the hardware infrastructure provided by the service provider, and we deploy the applications. We don't create any virtual machines for or the servers for deploying the application. Yeah, we can consider Salesforce.
Saptak, can you just mute your mic?
So any other questions?
Somebody had asked to define cloud.
Sorry, can you come back?
Define cloud, please.
Fine cloud.
Okay, I'll define cloud.
Define cloud, Ravi. She's asking about define cloud. Someone asked that question.
Okay, define cloud. So cloud is basically like the virtualized applications or the virtualized servers where we are deploying the our services or our instances on the service providers infrastructure. So if for example consider the Microsoft Azure. So Microsoft is maintaining the data centers across the globe, and we will create the instances, or we will create the applications on top of the infrastructure that they are maintaining. So we are just renting out the data centers or the physical hardwares provided by the Azure or the Microsoft or any cloud vendor, and we are just using those particular services. No, PaaS PA is like platform as a service is not only for the OS. So platform as a service is basically for the applications that are running. So like we don't need any underlying OS for in the past, like platform as a service and infra like software as a service. So we just deploy the applications and we run it. Whereas in the software as a service, it's all about the installing the softwares like the Google Docs or or the uh, Google Images or the Gmail. So all everything comes under the software as a service. Whereas the SQL DB or the websites or the web applications will come under the platform as a service. No, Azure cannot be considered as an example of platform as a service. So Azure is basically the cloud company, like it's a like a cloud provider. So it's a cloud service where a platform as a service is one of the offering type. Okay, so any more questions? No, local application does not come as SaaS. So for example, like earlier we have you like we used to use the Microsoft Word documents or the Excel sheets or the PowerPoint presentations in our local machine, right? So now the same way we are using the Google Docs or the SharePoint Docs or the Microsoft Docs on a web browser. So that we call it as a software as a service, where like whatever the local whatever softwares that we have used in our local machine, now we are using them over the internet. So which types of programs we are running? We are running. So like we can run the Python applications, or we can run the Java applications, or we can run the .NET applications, or like any other programming language. Or we can use it for we can deploy in the cloud. Okay. So next we see like what are the different cloud deployment models. So in the cloud deployment models, we have like mainly we have four deployment models: private cloud, public cloud, hybrid cloud, and the community cloud. So these are four deployment models which are applicable for the cloud computing. So first we will see what is a private cloud. So private cloud is basically it is accessible only by the organization that pays for it. It is very expensive, but it is completely secured, and we will have our own dedicated infrastructure provided by the cloud service provider. So that particular whatever the particular infrastructure that we are paying for will be used by only by a single organization, and it's not shared for the different organizations or for the different companies. So for example, if I own a company and I want to have my secured environment, like isolated environment or the isolated infrastructure, I just pay for the private cloud to the service to the cloud service provider, and I get the dedicated infrastructure which will not be shared across to any other companies or any other organizations. So private cloud is mostly same as the like the on-premises infrastructure, where we will be maintaining our own data center, or where we will be maintaining our own servers. So next one is the public cloud. So public cloud is basically like the cloud that can be accessed by anyone over the internet. So whoever has the any person in the world who has with the internet connection can access this public cloud, and it is owned by the cloud provider. So we whatever the cloud service providers that we have today, like AWS or the Microsoft or the Google or the IBM or the Oracle. So all these are the examples for the public cloud. So public cloud is basically like the cloud that can be accessed from anywhere in the world through the internet. So next one we have is the hybrid cloud. So hybrid cloud is basically like the mix of both private and public clouds. So where only few services that we use from the cloud, like from the public cloud environment, and remaining we will host them on the private cloud. So for example, if we want to maintain any sensitive data, or if we want to maintain any confidential data, we use this hybrid cloud in that scenario, where like we use the private cloud for saving or for storing all the data, all the confidential data and the sensitive data in the private cloud, and the remaining applications or the remaining data we will be storing it on the public cloud. Next one we have is the community cloud. So where community cloud is basically like It's a dedicated infrastructure for the organizations we who which works with the same set of requirements. So for example, we have the government organizations where or we have multiple government sites that we are working today, that we use in our daily life. So all the government websites or all the government owned applications will be working with the same types of requirements and same types of and same set of security policies and same compliance types. So to follow to have all the applications with the same set of policies to be followed, we use this community cloud. So this community cloud will be created based on the set of security requirements that we need, or based on the compliance types that we follow, or based on the privacy that the applications need. So whatever the organizations or what are all the applications that are following the same set of policies or the same set of rules will be hosted on the community cloud. So for example, if we have the bank internet banking login applications, so almost all the banking applications will follow same security architecture and the same security rules. So all the yeah. So Aparna, to answer our question, yeah, community cloud is provided for by all the cloud providers or the cloud vendors. So someone you are asking, I have a Linux software run in server. How he run? I am using Windows Server. Then how? Yeah, you can run any application on any of the OS. Basically using the platform as a service, you don't need any underlying OS or any underlying server. So you can run any application. Okay. So any other questions, guys, on this deployment models? So now we will see what is the serverless computing. So serverless computing is basically the platform as a service model where we don't need any underlying operating system or any underlying server for performing the activities. So for example, if I want to host a web application. So in the earlier days when we used to have the on-premises infrastructure, we need to have the server, we need to have the OS installed in it, we need to have the web server configured in it, and then we need to host that particular web application on that server so that the application will be accessible for the end users. But now, in the cloud infrastructure, we don't need any server or any hardware or any operating system for deploying the applications. So it's basically whatever the cloud infrastructure or whatever the physical hardware that is provided by the cloud service providers will be just using that hardware infrastructure, and we will run the applications on that on infrastructure. So there is no underlying server or any underlying infrastructure we need. So we just develop the developers will just develop the code, and we will build it on and we will deploy onto the under in the core infrastructure. And it is charged the charge is based on the computation, the number of process it is running, or the computation it is taking. So it is charged based on the computation and the process of that particular application. It's not like that we don't use the server completely or the infrastructure completely. We use the servers and use the infrastructure, but we don't manage those servers. So the management of the server, the maintenance and the management of the servers will be completely taken care by the vendor, and we don't even know where our application, in which server our application has been deployed. So the two biggest advantages of the cloud computing is scalability and elasticity. So for example, scalability. So what do you mean by the scalability? So scalability is basically it is used to meet the increases demand in workload. So for example, if we all use the Flipkart and Amazon applications, right? So we will be having the big billion days or some great Indian festival offers for the during the festival seasons. So for example, the Flipkart has configured their application or their network for managing the load of 1 lakh users per minute or per second. And during the big billion days, they expect that 1 lakh users traffic to 10 lakh users access the application, and the server might crash if there is no proper scalability configured. So scalability is used in this scenario where with the use of the scalability, Flipkart, like the server that the used managed by the Flipkart or that are used by the Flipkart will be auto scaling based on the traffic to increase that particular to increase the traffic to manage the increase in the traffic. So basically, like, it is like long term and they adopted long term planning and adopted to uh, rate to manage the expected increase. So they are expecting that these many users are will be hitting our website at this particular time, and we need these many servers or these many instances to be available on this particular time to manage this much of traffic. So for example, they might be using 100 servers they might be using 100 servers for managing like 1 lakh users traffic, but they are during the big billion days or during the offers, like they might be expecting like 10 lakh users to access the application, and instead of those 100 servers they might need some thousands of servers for managing the traffic. So the scaling of these applications during the specific time or during the specific period to manage the load, we call it as a scalability. Whereas we have the next one we have is the elasticity, where like elasticity and scalability both looks like both sounds like the same, but the only difference is like elasticity is used only for managing the load for a shorter span of time. So for example, if we just need to increase, like if we just need to manage the traffic or manage the workload for around half an hour to 1 hour, in that case the servers will be elasticity, like we use this elasticity concept, and the servers will be increasing. Like we don't increase the servers in the elasticity, but we increase the configuration of that particular servers in the elasticity. So for example, if we have a server with 8 GB of RAM, and like generally we use only 5 to 6 GB of RAM, and remaining 2 GB is not utilized. But there is a particular period of a time in a day or in a week where all the batch jobs are running and the server is completely getting utilized, and still the server is getting hanged up with the process is not utilized with the overutilized. So in that case, for only for that particular period of time when the batch jobs are running or the parallel processings are happening, we use this elasticity concept, and we can increase the configuration of the particular server from 8 GB to 16 GB. And even if the 16 GB is not sufficient, we can further increase it to 24 GB or like 32 GB. So based on like the configuration will be increased till the application or the till the server is managed to the application load or the traffic load. So whereas in the scalability, we just increase the number of servers or the number of instances, putting the application on the load balancing on all the instances. Is this clear? Like you understood the difference between elasticity and scalability. So next one we have is a fault tolerance. So what is a fault tolerance? Fault tolerance is basically the ability of a system to operate without any interruption when any of the components or any of the hardware components or the software components fail in that particular instance. So for example, if we have a CPU running or if we have the network like that is configured to that particular instance, so if there is any network outage and the server is not able to communicate with any other servers or any other instances in the network, so at that time we use this fault tolerance concept, where immediately the traffic from that particular server will be failed over to the secondary server, and there will be no downtime involved here. So immediately, like, when the server is not responding, the traffic will be immediately failed over to the secondary server. So for example, if I have an application running and if the application running on one of the server, and that the network of that particular server has a outage, or there is a CPU failure, or there is any other software that has been crashed, so the application will not be accessible. So immediately the fault tolerance will detect the fault that has been happened, like it will detect that say, some of the components of the server has failed, and the traffic will be immediately migrated or immediately failed over to the secondary server without any downtime. So next one we have is the high availability, where like high availability is also similar to the fault tolerance, but the only difference is like there will be a minimal downtime for the high availability servers or the high availability applications. So basically, high availability is calculated uh, as the 5 nines in the standard IT terminology. So 99.999% is considered as the high availability for the any servers or for any applications, keeping in mind that providing 100% uptime for any of the applications is impossible. So 99.999 is the standard high availability time that is provided in the IT standards or in the IT terminology. So here, like since the high availability and fault tolerance can be sounding as same, but the difference is that in the fault tolerance we don't need any downtime, where because like the applications or the network that has been failed on the server one or on the primary server will be immediately failed out to the secondary server, whereas in the high availability it will like there will be minimal downtime for failing over the application. So fault tolerance is basically used in such type in the critical applications where like the government organizations or the like army controlled applications or the health sector applications. So like which are critical and which are like which will be a huge loss if the application went down. So in such scenarios we will be using the fault tolerance. And high availability we will use for the application where the minimal downtime is accepted. So is this clear? So you can just shoot out like if you have anything. Okay, thank you guys. Thanks for joining this session. So if we can just go through, like we will be uploading this recording and the material to our platform. So you can just go through the explain fault tolerance. Okay, so fault tolerance. So Sajjan, like what fault tolerance is like? So for example, if we have an application and that application is running on the two instances, like we call it as a primary instance and the secondary instance. So by any cause or by any scenario, if the instance primary instance that goes down, the application will not be accessible in the general scenario. But in the fault tolerance, when the application is down, like it will be immediately when the in the primary instance is down, it will be immediately failed over to the secondary application, and the application will be accessed from the secondary server. Okay. Sure, like it's not the difference between PAS and serverless. PAS works with the core concept of serverless computing. So where we will not have any underlying servers, but like we will be running the applications on the core infrastructure that is provided by the service providers. Yeah, so we can mitigate this fault tolerance like by architecting the applications with the fault tolerance system. So like basically like keeping the applications in the hosting the applications in the multiple servers, providing the fault tolerance to the system, like we'll be having the continuous replication across the servers. So all these using all these we can mitigate this fault tolerance. Are getting used how traffic. Yeah, so the traffic will be handled like we will be using the load balancing concept where the traffic will be routed to all the servers. So no server will get overloaded and no server will get underutilized. See, PA is a platform as a service which is one of the cloud offering. Pay as you go is basically like the type of subscription or like the charges that we pay for the way how we rent the cloud applications or the cloud services. Pratik, like we will be updating this material in the platform, the nosfer.com, so you can go through that. Yeah, AWS Lambda and Azure Functions are the examples of PaaS. So we have other one apart from the fault tolerance, we have the other one is the high availability. Okay, so if there is nothing, like we can close this session. Thank you guys. Thanks everyone for joining.